Welcome to our audiobook reading of Barry Hillier's From the Transactional Age to the Intelligence Age, an automotive AI ebook. Whether you're driving between dealerships, sipping your morning coffee, or just need to absorb this content hands-free, we're here to bring you the complete book experience in audio format.
What makes it special is that Hillier isn't writing from some ivory tower after all the dust has settled. He wrote this from inside the transformation while it's happening, which gives it a completely different feel than your typical business book about AI.
Exactly. Most books about technology come out after the patterns are clear, after we know what worked and what didn't, but Hillier is essentially saying, look, we're all figuring this out together, and we need better frameworks for thinking about it right now, not 5 years from now. And that's why we wanted to provide this as an audio reading, because busy automotive professionals need to absorb this content while they're moving.
Right, and he makes this fascinating argument that the automotive industry believes it's successfully implementing AI, but most organizations are actually building what he calls coordination debt without realizing it. They're accumulating smart tools that can't work together as a system, and that's creating more problems than solutions.
What we're diving into today is a 12-chapter journey that moves from diagnosis to prescription. The first part completely reframes the AI conversation, moving away from what tools should we buy to what kind of organization are we becoming. The middle section diagnoses what's happening right now across dealerships and OEMs, and the later chapters get into the practical work of building what he calls intelligence architecture.
And there's this comprehensive appendix with actual assessment tools, implementation frameworks, and vendor evaluation criteria. It's not just theory, it's meant to be used in the real world by people running automotive businesses.
The book introduces some new language that isn't common in the industry yet, terms like intelligence architecture, coordination debt, and the 7-stage maturity framework. These aren't technical concepts. They're organizational and strategic ones that help leaders think differently about their AI investments.
What I find compelling is his central argument that we're not just in another technology cycle. We're moving from what he calls the transactional age to the intelligence age. And that shift changes everything about how organizations need to think about coordination, learning, and customer relationships.
So whether you're listening in your car, at your desk, or wherever you get your best thinking done, we're going to take you through this book systematically. Today we start with Hillier's Note to the Reader, which sets up the entire framework, followed by Chapter 1, where he makes the case that most organizations can't actually adopt artificial intelligence the way they think they can.
This should be eye-opening for anyone who's been wondering why their AI initiatives feel productive but somehow don't seem to be transforming their organization. Let's dive in.
Starting with the Note to the Reader. Note to the Reader. If you are feeling nervous about AI or uncertain, you aren't alone. This book is being written from inside a transition, not after it. There's a big difference. Most books about technology are written once patterns are already visible. Best practices have formed. Case studies exist. Language has stabilized. The work becomes one of explanation and execution. Artificial intelligence for the automotive industry has not yet reached that kind of moment. Across dealerships, OEMs, and suppliers, AI is present and being tested as an industry-wide transition begins to take shape. Tools are live, pilots are running, platforms are being integrated, results are being measured. By any definition, the industry is doing AI. And yet, beneath that visible progress, something much more fundamental has begun to shift. For the first time, AI is enabling intelligence to be built within organizations beyond humans. This can be designed in a way that humans cannot understand due to the complexity and enormity of the data the organization owns. We no longer have to rely on individual expertise, not isolated analytics, but as an organizational capability for intelligence that will change the industry forever. That change does not arrive with a roadmap. It never has. When mechanical power first entered manufacturing, organizations didn't simply buy engines. They had to invent factories, workflows, safety standards, supply chains, management systems, and entirely new ways of coordinating work. Long before mass production became obvious, there was a prolonged period of experimentation, uncertainty, and foundational construction. The early decades of computing followed the same pattern. Software appeared before data strategies. Systems spread before architectures existed. Value was created long before understanding stabilized. AI now sits in that same formative phase, which is why this book is not structured as a guide to tools, vendors, or use cases. It is an attempt to understand what kinds of organizations this technology makes possible and what kinds it quietly makes harder to sustain.
As you read this book, you will notice that it does not begin by telling you what to build. It begins by examining what is changing, how AI works, how coordination occurs, and why many current AI efforts feel productive while also complicating leadership decisions. Later chapters introduce language that is not yet common in the industry, ideas such as intelligence architecture and coordination debt. These are not technical constructs, they are organizational ones. They are strategic decisions. As in any new era, we need words and concepts to help guide us into the unknown. None of us has experienced anything like AI before, and we need a shared understanding that will allow us make sense of the transition. Throughout this book, the word intelligence is not used to describe software capability. It refers to an organizational condition that is only possible with AI. The ability for a company to continuously learn from every experience, integrate context across functions, anticipate rather than react, create transferable wisdom, and coordinate its actions as a system rather than as a collection of departments. And when this book speaks about intelligence architecture, it does so deliberately. That term is derived directly from artificial intelligence architecture, serving as a framework for the idea that an organization can be intelligent beyond human capacity. At a technical level, artificial intelligence only becomes powerful when it is supported by architecture, data foundations, learning systems, memory layers, orchestration, and feedback loops that allow intelligence to accumulate, move, and shape behavior. Without that architecture, AI exists only as isolated tools. I describe this to help the reader understand the foundations of this transition. This book discusses why the industry's history in itself has limited organizations. The majority of automotive dealerships are deeply entrenched in tool usage within their organizations, but drawbacks are already being identified. Tools are useful but fragmented, capable but narrow, impressive but structurally constrained. This is a byproduct of the digital age, and that age is now dead.
This is how most organizations test AI for the first time. Chat systems, predictive modules, recommendation engines. Automation features are embedded in existing platforms. These applications create visible value. They improve functions. They optimize processes. They deliver measurable returns. But they do not, on their own, create organizational intelligence. Because intelligence does not emerge from individual systems. It emerges from how systems are designed to work together through an intelligence architecture. As long as those architectural foundations live inside isolated applications, organizational intelligence remains something that can only be used in silos without a full understanding of the whole. This isn't the intelligence that we expect from AI, as it cannot see how the organization actually functions, coordinates, and makes decisions based on a full view of situations, nor does it have existing or historical context. This is not the fault of AI. It's because the organization hasn't built the architectural foundations necessary to fully benefit in an AI era. But when those same architectural foundations are deliberately elevated out of individual tools and designed at the enterprise level, something important changes. Intelligence stops living inside systems. It starts living inside the organization. This is when the promise of AI is realized. At that point, what matters strategically is no longer that the intelligence is artificial. What matters is that the organization itself has acquired the ability to learn from experience, retain understanding, anticipate conditions, and coordinate action as a system. The intelligence may be artificial in origin, but it is no longer artificial in function. It is not an add-on. It is not a feature. It is not a system of separate tools. It is the underlying design of how the organization operates. This is why the language shifts in this book from artificial intelligence architecture to intelligence architecture, not to obscure the technology, but to reflect on where the real transformation actually occurs, as a foundation that connects systems and people together with AI to realize potential that wasn't possible at any time before now. When intelligence becomes architectural, the question stops being what the technology can do. It becomes what the organization itself is now capable of becoming.
When intelligence architecture is absent, AI adoption inevitably takes the form of accumulation. More systems, more dashboards, more recommendations, more specialized intelligence, and more work is required to align it all. If this sounds familiar to you, this is the condition described later in this book as coordination debt, the growing organizational effort required to reconcile intelligence that was never designed to operate as a system. I'm willing to bet that this is the place you likely are in your current AI efforts. Simply adding AI tools cannot resolve this. In fact, without architectural intent, it accelerates it, because each new intelligence system increases the amount of intelligence that must be coordinated manually. The full transformation this era offers doesn't come from the number of AI tools an organization deploys. It stems from whether the architectural foundations of artificial intelligence are deliberately incorporated into the organization's design and whether your team adopts it as a new way of behaving. That is what intelligence architecture refers to throughout this book, not a technology stack, but the strategic design of how intelligence is produced, shared, governed, and allowed to shape behavior at scale and in ways that can transform the automotive industry for decades to come. The ideas in this book are introduced gradually because they are not product categories. They are lenses, ways of seeing how organizations actually transform, how they operate, how they relate to customers, how they improve, how they decide, and ultimately how they shape what the industry itself becomes. These shifts are not understood in a single insight. They are built. Clarity in this domain does not arrive all at once, it compounds. If you want a cursory or quick understanding of AI, this isn't the book for you. If you want to understand AI and how it is affecting the industry and why, please keep reading. But don't worry, it isn't written to be complicated or technical. The first part of the book reframes the problem. The middle diagnoses what organizations are already experiencing. The later chapters move into architecture, maturity, and leadership responsibility. This progression is intentional. I have also included an appendix with tools to aid you. I provide a brief history of AI to help you understand the conceptual framework we are building today. I also provide a history of the automotive industry to show you that we have been through transformative stages before that have forced the entire industry to restructure, and yet we still survived. If in the early chapters, certain ideas feel unfamiliar or incomplete, that is not an accident. This book is not meant to provide quick answers. It is meant to reshape the questions leaders ask as the future is still being formed. Because the central risk of this era is not choosing the wrong AI tools. It is building the wrong organizational foundations while the industry is still early enough to shape them. Everyone reading this is, whether they intended to be or not, participating in that construction. By the end of this book, you should not simply feel more informed about artificial intelligence. You should feel clearer about what kind of organization you are in the process of building, and whether that future is being deliberately designed or assembled by default. Barry Hillier.
Now let's move into Chapter 1. You can't adopt artificial intelligence. Why tools don't become intelligence. Chapter 1. You can't adopt artificial intelligence. Why tools don't become intelligence. The automotive industry believes it is implementing AI. Walk into any dealership, OEM facility, or automotive supplier today, and you'll hear the same refrain, "We're doing AI." Then they point to ChatGPT usage, AI features in the CRM, machine learning in the marketing platform, and predictive analytics in the service system. They mention that their team is being trained on how to prompt. By any surface measure, the industry is well underway in its AI journey. And yet, almost all of this activity is aimed at the wrong problem. Most automotive organizations believe they are in the optimization phase of AI adoption, focused on selecting better tools, integrating them more tightly, and measuring AI ROI more accurately. In reality, the industry has entered something far more consequential, the architecture phase of an intelligence transformation. The problem is that this shift is happening without widespread recognition, and there are valid reasons why. There is no historical precedent for organizations becoming intelligent, no established discipline for designing intelligence at the enterprise level. There are no playbooks, so foundations are being laid without being intentionally designed. Because AI isn't understood yet, intelligence is entering structures built for transactions. Learning is emerging inside systems without the means to coordinate it or understand it. And organizations are unintentionally building architectures they did not mean to make. Here's what most automotive professionals think AI transformation looks like. You evaluate AI tools for different business functions. You pilot the promising ones. You measure the results. You scale the successes. You optimize the integration between systems. Eventually, you have an organization that uses AI effectively across all its operations.
Most automotive leaders still imagine AI transformation unfolding the way every major technology cycle before it did. 1. Evaluate tools by function. 2. Pilot the promising ones. 3. Measure results. 4. Scale what works. 5. Integrate systems over time. Eventually, the organization will be using AI across its operations. This approach makes perfect sense if we were still in the digital age. Digital systems were designed to automate work, standardize processes, and improve execution. CRM platforms strengthened sales operations. Marketing systems optimized outreach. Digital service platforms increased throughput and efficiency. Each wave made organizations faster and more measurable. None of them fundamentally changed what organizations themselves were capable of being. That is why the reflex still feels right. But we are no longer in the digital age. We have entered the AI era and an intelligence age. And the difference is not the tools, it is what the technology makes possible. Artificial intelligence does not just automate activity, it learns. It does not just execute processes, it forms models. It does not just optimize functions. For the first time, systems can observe the organization as a whole, learn from every interaction, and allow what is discovered in one area to reshape decisions in another. When that becomes possible, the organization is no longer innovative tools. It is intelligence on an organizational level. It is acquiring new capacities, how it understands customers, how it coordinates work, how it improves itself, how it makes decisions, how it reorganizes around what it learns. It is here where AI stops being something the organization uses. It becomes something the organization is built around. And the central question is no longer, what tools should we deploy? It becomes, what kind of organization are we now designing? The great AI misunderstanding.
Consider two automotive organizations facing the same challenge: improving service experience and increasing retention. Organization A, AI is simply a collection of tools that implement AI-powered scheduling, deploy chatbots for customer communication, use machine learning to identify at-risk customers, applies AI recommendations to service follow-up, and measures efficiency gains and satisfaction scores. This organization is truly using AI. Each system is intelligent. Each deployment produces insight. Each function improves, but intelligence lives inside tools. There is no shared memory, no unified context, no enterprise learning layer. Each system optimizes what it can see. Leadership reconciles the rest. The organization becomes more efficient. It does not become intelligent. Organization B, AI has been built as an intelligence architecture. This organization builds unified customer intelligence that learns from every interaction across sales, service, and communications. This AI intelligence architecture designs predictive systems that anticipate needs before problems surface, creates coordination layers that shape decisions across departments, not just within them, establishes continuous learning loops where outcomes reshape future behavior, and measures its ability to anticipate, adapt, and align, not just execute. This organization is not simply using AI, it is about designing the conditions under which intelligence can exist within the enterprise. AI tools still exist, models still run, vendors are still involved, but they are selected, connected, and governed as parts of an intelligent system. The architecture comes first. The tools serve it. The first organization improves performance. The second constructs new capabilities. One gets faster, the other becomes fundamentally different. Why this matters? This is not an implementation distinction. It is the difference between applying intelligence and being structured around it. And that difference determines whether intelligence compounds across the enterprise or fragments inside it.
Tools versus intelligence architecture. The most costly mistake the automotive industry is making about AI is not a technical one. it is conceptual. Most organizations believe they are optimizing AI use. In reality, they are deciding what kind of organization they will become, often without realizing that their current AI adoption and use is unknowingly shaping their future architecture. This is why understanding the implications and benefits of how you adopt AI are critical. If you believe AI is primarily a tool category, your strategy naturally centers on selecting and integrating individual tools. You measure ROI on specific AI applications. You organize AI adoption around existing departmental structures. You treat AI transformation as a technology project. You expect a gradual improvement in current capabilities. This approach produces local intelligence. It makes functions stronger. It improves processes. It creates visible gains. But it does not produce organizational intelligence. And this is a critical distinction. If you understand that AI enables intelligence to exist as a system, your strategy changes. You stop asking which tools to buy. You start deciding what capabilities the organization itself must acquire in an AI era. You focus on developing systematic capabilities across organizational functions. You measure intelligence advancement and competitive differentiation. You organize transformation around coordinated learning and decision-making. You treat AI transformation as organizational reconstruction. You expect breakthrough capabilities that weren't previously possible. This approach does not optimize departments. It reconstructs the enterprise. The organizations taking the first path will get better at what they already do. The organizations taking the second path will begin doing things that their competitors structurally cannot. Why AI architecture matters for automotive leaders, the current AI landscape reality. Let's talk about where the automotive industry actually stands. Most organizations are not building intelligent systems. They are accumulating intelligent tools. AI today primarily exists inside individual platforms, inside specific workflows, inside functional silos, inside vendor boundaries. Even the most advanced deployments are typically department-owned, locally optimized, loosely coordinated, and manually reconciled.
This is not failure. It is precisely what early-stage adoption always looks like. But it is not intelligence. There is no systemic learning layer, no unified organizational memory, no coordinated decision fabric, no enterprise-level model of the customer, the operation, or the market. What exists are pockets of intelligence within the organization that still rely on people and meetings to make sense. The results are tangible: faster analysis, better targeting, improved prediction, localized optimization. But what is not yet emerging is what defines an intelligent enterprise: cross-functional learning, enterprise-level anticipation, coordinated intelligence, and compounding organizational advantage. And this leads to the most essential reality of all. There are no mature automotive intelligence architectures to copy. There are only early experiments, which means every serious automotive organization is already building something, whether it recognizes that work as architecture or not. The only question is whether what is taking shape is being designed for the future or assembled by default. Are you really implementing AI in your dealership? You do not need to stop using tools. I just wanted to let you know that the work in front of you is not to stop deployment, but to reassess what your existing AI efforts are actually constructing. The remainder of this book examines how the AI you already have is shaping intelligence within your organization. Because the frameworks, methodologies, and practices that will define automotive intelligence are not being purchased. They are being formed right now by organizations willing to think architecturally about intelligence rather than tactically about tools. The architectural thinking requirement. Building an AI intelligence architecture requires a different kind of strategic thinking than that needed for previous technology transformations. Instead of asking, which AI tools should we implement? Ask, what intelligence capabilities do we need to develop? Instead of asking, how do we integrate our AI systems? Ask, how do we coordinate organizational learning and decision-making? Instead of asking, what ROI do we get from AI investments? Ask, how does AI intelligence create competitive advantages that compound over time? Instead of asking, how do we manage AI transformation projects? Ask, how do we build organizational capability for continuous learning and adaptation? This shift from tactical AI adoption to strategic AI architecture development is what separates organizations that will define the future of automotive intelligence from those that will spend the next decade trying to catch up.
The pioneer opportunity. This moment is not valuable because AI tools are powerful. It is helpful because intelligence is now buildable. For the first time, organizations can embed systems that learn from experience, coordinate across functions, and improve their own behavior over time. That makes this an architectural moment, and architectural moments are rare. Don't worry about being behind. The playbook is still being written. The organizations that figure out how to build effective AI intelligence architecture over the next 2 to 3 years will establish approaches that others follow for the next decade. From tools to intelligence. The shift from transactional age operations and digital age strategies to true intelligence age organizations will not happen automatically in the automotive industry. It must be architected. Our current reality is being shaped quietly, structurally, and often unintentionally by the decisions leaders are making right now. Every AI pilot, every data integration, every system selected, every organizational boundary left in place. These are no longer just technology choices. They are architectural acts. They are determining where intelligence is allowed to exist, how it can move, and whether it will ever be able to operate as a system within your organization. This is not adoption. This is not optimization. This is not another technology cycle. This is an architectural change. And architecture, whether designed deliberately or assembled by default, always shapes what an organization eventually becomes. Every automotive leader wants a plug-and-play solution, and I hate to break it to you, there are none. This is why this is pioneering work. There are no finished playbooks, no stable patterns, no risk-free paths, no vendor stacks that quietly solve this in the background. The organizations building intelligence today are inventing the standards the rest of the industry will eventually inherit. What takes shape over the next few years will not simply influence performance metrics. It will determine which organizations develop capabilities that others structurally cannot. It will determine who sets the operating assumptions that the rest of the industry works within. It will determine who defines what automotive intelligence actually becomes. The real question is no longer whether you are ready for AI. Readiness is no longer the threshold, it is the minimum. The real question is whether you are willing to accept responsibility for your organization's architecture, to build before certainty exists, to design before best practices are available, to commit to shaping capabilities that have never lived in this industry before. Whether you choose to or not, something is already being built somewhere. The only question is whether it is being designed intentionally. Welcome to the intelligence age, the journey ahead.
That concludes Chapter 1 of From the Transactional Age to the Intelligence Age. Hillier has established his fundamental argument that the automotive industry thinks it's implementing AI, but it's actually making architectural decisions about organizational intelligence without realizing it.
The key insight is that we're not in the optimization phase of AI adoption. We're in the architecture phase of an intelligence transformation. And that changes everything about how leaders should approach their AI strategy.
In our next audio reading session, we'll continue with Chapter 2, Why This History Determines Your AI Outcome, where Hillier takes us through 70 years of AI development to show why the coordination problems that stalled AI progress for decades are now appearing in automotive organizations today.
It's a fascinating historical perspective that explains why so many current AI initiatives feel productive while somehow not achieving true organizational transformation.
Thanks for listening along with us. Welcome back to our audiobook reading of Barry Hillier's From the Transactional Age to the Intelligence Age. Why This History Determines Your AI Outcome.
This chapter is fascinating because Hillier takes us through 70 years of AI development to show that the problems automotive organizations are experiencing today aren't new. They're the same coordination challenges that stalled AI progress for decades until breakthroughs finally made organizational intelligence possible.
What makes this historical perspective so valuable is that it explains why so many current AI initiatives feel productive but don't achieve true transformation. The patterns are remarkably consistent across 7 decades of AI development.
And it shows us that we're not in some experimental phase. We're standing on the foundation of solved problems. The technical barriers to intelligence coordination have been overcome. The question now is whether automotive organizations will learn from this history or repeat it.
Let's dive into Chapter 2. Chapter 2. Why? This history determines your AI outcome. It helps to reflect on how long the pioneers of artificial intelligence struggled with the same problems the industry is now encountering. What you are experiencing today mirrors what the AI pioneers in the field have experienced as well. For 70 years, artificial intelligence failed for the same reason most organizations fail with AI today. Not because the ideas were wrong, not because the ambition was misplaced, but because intelligence was being pursued without an architecture capable of supporting it. Again and again, the field produced breakthroughs that looked like intelligence, and again, those breakthroughs collapsed. What follows is not a technical history, it is a structural one, because every major failure and every real breakthrough in AI's development traced back to the same invisible boundary. Systems could compute, but they could not coordinate. They could not think. Until they could, intelligence could not scale, and neither could the organizations that tried to build around it. What follows isn't a history lesson, it is context on AI and how we got to this moment. The dreamer who started it all, 1950. When Alan Turing sat down in 1950 to write what would become the most influential paper in the history of artificial intelligence, he was already dissatisfied with the way the problem was being framed. Can machines think? Was the fashionable question of the day, but Turing found it philosophically slippery and practically useless. Thinking was too abstract, too undefined, too easy to argue about, and impossible to measure. So he reframed the challenge. Instead of asking whether machines could think, he wondered whether they could behave intelligently enough that humans could not reliably tell the difference. If a machine could participate in conversation in a way indistinguishable from a person, then the debate about inner experience no longer mattered. Intelligence would have crossed from theory into operation.
What later became known as the Turing test is often remembered as a parlor challenge. But it was something far more consequential, a declaration that intelligence was not a static property, but a dynamic capability. Turing was pointing away from programmed responses and towards systems that could adapt, respond to context, and coordinate behavior in the face of uncertainty. He understood, long before the technology existed, that real intelligence would not come from better rules, but from machines capable of learning, integrating information, and modifying their own internal structures over time. For the automotive world, his implications were quietly radical. Turing envisioned machines that could manage factories, optimize logistics, and coordinate complex processes not through fixed instruction sets, but through evolving internal models of reality. He was describing, without yet having the words for it, the foundations of what would one day become intelligence architecture. Turing did not live to see even the first serious attempt to realize this vision. He died in 1954 when computers still filled rooms and possessed less power than a modern key fob. But he left the field something more enduring than a prototype. He gave it a direction, away from automation, toward intelligence, the reality check that nearly ended the field. By the end of the 1960s, optimism that machines could think had again outrun capability. Early neural networks had demonstrated that machines could recognize patterns and improve with exposure. For a moment, it seemed as though the dream of learning machines was finally within reach. Then Marvin Minsky and Seymour Papert published perceptrons. Their analysis was mathematically rigorous and, within its scope, entirely correct. They showed that the neural networks of the time were incapable of solving entire classes of problems, specifically those requiring the coordination of multiple dimensions of information. It could learn simple patterns, but couldn't handle complex problems that required coordinating multiple types of information simultaneously, precisely the kind of coordination that automotive organizations would eventually need for intelligence architecture.
The gap between promise and reality was about to become painfully obvious. What followed was not a correction. It was a collapse. Funding evaporated. Neural network research was quietly abandoned. The field concluded not that its methods were immature, but that they were fundamentally flawed. The first AI winter set in, and beneath it, a deeper misinterpretation took root, that intelligence could be assembled solely through explicit reasoning. This was known as symbolic AI. Frank Rosenblatt died 2 years later, never seeing the problem he had exposed finally solved. Two paths into the same wall. As neural approaches to AI fell out of favor, artificial intelligence divided into two dominant traditions. At MIT, intelligence was pursued through logic. If learning were unreliable, perhaps intelligence could be formally described and systematically encoded. This gave wind to the concept of symbolic AI. Symbolic AI attempted to capture reasoning itself, building systems that manipulated structured representations, followed rules, and derived conclusions through inference. Expert systems emerged from this tradition, and, within narrow domains, they worked remarkably well. Medical diagnostics, equipment configuration, and financial decision trees all demonstrated that machines could outperform humans under tightly constrained conditions. But they could not evolve. They could not transfer knowledge. They could not reconcile conflicting signals or adapt to changing conditions. Each system was an island of intelligence, brittle and expensive to maintain. At Carnegie Mellon, a different emphasis prevailed. Researchers such as Alan Newell and Herbert Simon focused on building machines capable of functioning in complex environments. Their work produced early robotics, automated theorem provers, and the first systems that demonstrated measurable business value. The R1 expert system, built for Digital Equipment Corporation, eventually saved the company tens of millions of dollars annually. Yet these successes encountered the same boundary. Each system operated independently. None could coordinate. None could learn across contexts. None could build organizational intelligence. None could think.
By the late 1980s, the limitations became undeniable. Expert systems collapsed under their own complexity. Every new rule destabilized others. Maintenance overtook innovation. The second AI winter arrived. What the field had run into twice was not a failure of ambition. It was a failure of architecture. The ideas were bold enough. The funding was real. The talent was unquestionable. What was missing was a structure capable of supporting intelligence itself. And this is where the history of AI stops being academic and starts becoming uncomfortably familiar. The automotive industry is now standing at the same threshold that stalled AI progress for 70 years, not because leaders lack ambition, vision, or investment. Automotive executives are among the most strategically sophisticated in business. They've successfully navigated multiple technology transformations, built operations of extraordinary complexity, and consistently delivered results under intense competitive pressure. But the dominant response to AI has been acquisition rather than architecture. The industry is approaching AI the way it approached every previous technology wave. Identify the best tools, implement them systematically, measure the results, and scale what works. This approach built the modern automotive enterprise. It worked for manufacturing automation, digital systems, and connected platforms. AI is different.
The current approach mirrors exactly what failed in AI for decades. More platforms designed without coordination protocols, more pilots launched without learning the architecture. More embedded capabilities are deployed without systematic integration. The same hope that once surrounded perceptrons and expert systems now surrounds modern AI tools. That if enough individual capability is developed, organizational intelligence will eventually appear. History suggests the opposite. Intelligence does not emerge from isolation and linear tools. It emerges from architecture. It emerges from coordination. It emerges when the foundations that allow learning, memory, and decision-making to operate as a unified system are deliberately constructed. The pattern is predictable. Every major AI breakthrough has come not from better individual algorithms, but from solving the coordination problem that allows intelligence to function as a system rather than fragments. And when every major technology reaches that realization, it always enters its least glamorous phase. Not a race for more sophisticated tools, not a search for additional applications, but the methodical rebuilding of foundations, of data architecture that enables shared learning, of systems designed for coordination rather than optimization, of organizational structures that can hold intelligence rather than just use it. This is the unglamorous work that determines what becomes possible long after the vendor presentations end and the excitement fades. This is exactly where Geoffrey Hinton succeeded, even though everyone else had given up. The long rebuild. While most of the research world turned away from neural networks, Geoffrey Hinton didn't. He believed the early failures weren't proof that learning machines were impossible. They were proof that the structure was incomplete.
In 1986, he and two collaborators showed how neural networks could finally be trained in depth, layer by layer, so that mistakes made at the output could travel backward through the system and reshape how it learned internally. Instead of hard-coding intelligence, the machine could now build it. This solved exactly the problem Minsky had exposed. Neural networks could finally coordinate multiple layers of information to handle real complexity. Almost no one paid attention. The machines were still too slow, the data sets too small, commercial interest lay elsewhere, so Hinton did something unusual. He stepped out of the spotlight and into patience. He moved to Toronto, not for capital, for time, supported by CIFAR, Canadian Institute for Advanced Research, and the University of Toronto. Hinton built a lab that pursued a single, unfashionable question for more than 2 decades: how complex systems learn to organize themselves. While the rest of the industry optimized applications, his group studied the structure of intelligence itself, how depth stabilizes learning, how representations emerge, how multiple signals are reconciled inside a single model. A generation of researchers passed through that environment. They were not trained to build products, they were trained to solve coordination. When hardware finally caught up, when GPUs made large-scale parallel computation practical, the theories were ready, and when they were tested, they worked. When intelligence crossed a threshold. In 2012, that proof arrived on a global stage. ImageNet was the world's most demanding visual intelligence benchmark, a competition designed to test whether machines could recognize the real world across thousands of categories. For years, progress had been slow and incremental. Then a system built in Hinton's lab shattered the field. It didn't just perform better, it performed differently. It showed that layered learning systems could absorb massive complexity, organize it internally, and generalize what they learned into new situations.
Within months, every major technology company began quietly rebuilding around this realization. New research labs appeared almost overnight. Entire software stacks were replaced. But the fundamental shift wasn't about vision. It was about coordination. Language systems began integrating knowledge across domains. Learning systems stopped executing scripts and started developing strategies. DeepMind showed that perception, memory, and planning could operate inside a single intelligence. Multi-agent systems began coordinating specialized capabilities into collective problem solving. For the first time, artificial intelligence was no longer a collection of narrow tools. It became architectural. What is often missed in this story is where that threshold was crossed and how it spread. The deep learning revolution did not begin inside a product company. It started inside a Canadian research culture that valued long horizons over quarterly returns. While much of the world cycled through hype and winters, Toronto became a place where neural networks were allowed to fail, mature, and evolve without needing to justify themselves as products. Geoffrey Hinton's lab, supported by the Canadian Institute for Advanced Research, quietly trained the generation that would seed the global AI economy. When the breakthrough finally arrived, the knowledge didn't stay in Canada.
It moved outward. Google rebuilt its intelligence stack on deep learning. Meta reorganized around neural architectures. DeepMind fused deep learning with reinforcement systems. OpenAI extended these foundations into general intelligence platforms. China industrialized them. Silicon Valley financialized them. Every major technology platform of the last decade has been built on research that matured in an environment where immediate returns were never the primary objective. Canada supplied the patience, the world supplied the leverage, and the result was not better tools. It was a new technological foundation, one capable of learning, coordinating, and scaling intelligence itself. That is the foundation Automotive is now standing on. Not a wave of software products, not tools to be layered into existing processes, but the downstream completion of unfinished ideas, now able to exist as intelligence. Why automotive intelligence is now possible. For 70 years, artificial intelligence has run into the same invisible wall. Systems could compute with extraordinary speed, classify patterns with superhuman accuracy, and optimize individual processes beyond human capability. But they could not coordinate, they could not reconcile conflicting signals from different domains. They could not maintain context across extended interactions. They could not allow learning discovered in one area to reshape behavior in another automatically.
Each breakthrough created impressive capabilities trapped within its own boundaries. Expert systems that couldn't share knowledge, neural networks that couldn't transfer learning, optimization engines that couldn't see beyond their local objectives. That wall has now moved. Not because of a single invention, but because architectural foundations finally caught up to ambition. Learning systems are mature enough to maintain context across domains. Hardware scaled to support real-time coordination, data accumulated in forms that preserve relationships, not just records. Memory architectures emerged that enable shared organizational intelligence rather than isolated departmental analytics. For the first time in AI's history, coordination became both technically possible and economically viable. This is why automotive intelligence is now achievable. Not better automation or enhanced analytics, but organizations can learn, anticipate, and coordinate as unified systems. The exact boundary that constrained artificial intelligence for 7 decades is now becoming the defining boundary of automotive competition. Not whether AI tools can automate workflows, but whether intelligence can flow seamlessly across the entire enterprise, across departments that have never shared context, across decisions that have always been made in isolation, across time horizons from immediate customer interactions to long-term lifecycle management. Whether service insights automatically reshape sales approaches, whether inventory patterns instantly inform marketing strategies, whether customer behavior continuously optimizes operational decisions. From this point forward, competitive advantage will not be determined by which AI applications you deploy. It will be determined by whether your enterprise has been architected to hold intelligence, to accumulate it, coordinate it, and allow it to compound. The organizations that understand this architectural requirement will build sustainable advantages. The organizations that continue to accumulate tools will incur significant coordination overhead. And that difference will define the next era of automotive competition. That concludes Chapter 2 of From the Transactional Age to the Intelligence Age. Hillier has shown us that the coordination problems automotive organizations are experiencing with AI today aren't new. They're the same structural challenges that stalled AI progress for 70 years.
The key insight is that we're not in some experimental phase of AI development. The foundational problems have been solved. The technical barriers to intelligence coordination have been overcome. What we're seeing in automotive organizations today is the echo of historical patterns, not inevitable growing pains.
The difference is that now we have the architectural foundations that make organizational intelligence possible. The question is whether automotive leaders will learn from this history and build deliberately or repeat the same coordination mistakes that led to decades of AI winters.
In our next session, we'll continue with Chapter 3, AI Literacy for Automotive Leaders, where Hillier breaks down what AI actually is, how it fails, and what leaders need to understand to make good strategic decisions about intelligence systems.
It's a practical chapter that translates the historical lessons into concrete understanding that every automotive executive needs. Welcome back to our audiobook reading of Barry Hillier's From the Transactional Age to the Intelligence Age. We're diving into Chapter 3. AI Literacy for Automotive Leaders. What AI can do, what it can't, and what people get wrong.
This is a crucial chapter because it gives automotive leaders the practical understanding they need to make good strategic decisions about AI. Hillier isn't trying to turn executives into AI engineers, but he is giving them the literacy to understand what kind of systems they're introducing into their organizations.
What makes this chapter particularly important is that it explains how AI fails differently than traditional software. When traditional software breaks, it stops. When AI breaks, it keeps going confidently. And in automotive, confidently wrong can quickly become a customer experience disaster or a compliance problem.
The chapter is structured around the key concepts every automotive leader needs to understand about AI systems. It's technical enough to be useful, but written in plain language that busy executives can absorb while they're driving or between meetings. Let's get into Chapter 3.
Chapter 3: AI Literacy for Automotive Leaders. This chapter exists so you don't design blindly. If you're going to build AI intelligence in automotive, you need to understand what you're building. Not the math, not the code, not the promises, but the foundations. This chapter is not here to turn you into an AI engineer. It's here to give you the literacy required to make good strategic calls. What to invest in, what to avoid, what to pilot, what to govern, and what not to trust. This chapter is not meant to overwhelm you with technical jargon. It is about understanding what kind of systems you are introducing into an organization that was never designed to hold them. Because AI does not fail the way traditional software fails. When traditional software breaks, it stops. When AI breaks, it keeps going confidently. And in automotive, confidently wrong can quickly become a customer experience disaster, a compliance problem, or a liability event. What follows is a leader's framework, the handful of concepts that explain what goes right or wrong when organizations try to operationalize AI. The first misunderstanding: AI is not smarter software. Most automotive leaders approach AI the way they approach digital transformation. They think, buy a tool, plug it in, train the team, and measure ROI. That worked in the digital age because most tools were designed to automate a specific task within a specific department. They didn't need to understand the organization or make decisions. They needed to execute rules. AI is different. It isn't primarily a rules engine. It's a pattern engine. Traditional software runs on instructions. If X, then Y. AI runs on inference. Based on what it was trained on, Y is likely to work. That difference matters because it changes what you are buying. Remember, you're not buying a feature. You're buying a system that produces judgment-like output under uncertainty based on data, context, and objectives. Reader translation: AI doesn't behave like a tool. It behaves like a new kind of workforce, one that is fast and scalable, but inconsistent, improvable, and sometimes wrong.
What AI actually is, in plain language. At its core, AI is software that can do 4 essential things that once required human cognition, and it can do them all simultaneously. First, it can recognize patterns across massive amounts of information. Second, it can form predictions about what's likely to happen next. Third, it can generate language and content that feels natural and contextual. And fourth, it can take action inside your workflows and systems. This is why it feels magical, not because it thinks, but because it can detect patterns across volumes of information that we cannot process, model futures we cannot hold in our heads, and act across scales that no human system ever could. AI can ingest thousands of signals across customer behavior, service history, market movement, and operational conditions, and return an output that feels like experience. But it is not experience. It is a probability. Every AI output is a statistical inference about what is most likely to happen next, which means its intelligence is always bounded by 3 critical factors: what it has been trained on, what it can see right now, and what it is being optimized to pursue. Those are not vendor variables, they are leadership variables. They determine what intelligence is allowed to form, what intelligence is allowed to influence, and what intelligence is allowed to become. No platform can choose them for you. No model can resolve them for you. No partner can carry that responsibility, which is why human leadership becomes more critical in the intelligence age, not less. Not to override intelligence, but to design the conditions under which it is allowed to exist. It is also an indication of why humans are critical for intelligence as part of the design architecture. What AI is not, and why this matters in automotive. This is where most organizations fundamentally misread the technology, not because they overestimate what AI can do, but because they misunderstand what kind of system it is. AI is not a truth engine. It does not reveal reality. It models probability. It does not know. It detects patterns, applies what it learned during training, and generates outputs based on statistical probability, which means AI is never infallible. It will sometimes be wrong, confidently wrong, because confidence is a property of output, not accuracy. This is not a flaw, it is the nature of statistical intelligence. And it is why AI does not remove accountability, it redistributes it to the humans who direct and govern it. Because AI does not and never should operate on its own.
Because AI does not arrive autonomously. If intelligence is not governed, bounded, and architected with clear human oversight at decision points, it will either be constrained into irrelevance or allowed to make recommendations no one can audit or challenge. It will do too little because no one trusts it, or too much because no one is positioned to challenge it. AI is also not universal. Performance does not automatically transfer across domains. Models require scope, context, and boundaries. And AI is not cost-free. Every act of learning, inference, and coordination carries real operational cost. At scale, intelligence is infrastructure, not software. The strategic implication is not that AI is risky. It is that AI is foundational. It creates new organizational capability only when it is treated like an operating system for intelligence rather than a plug-in for tasks. Now let's examine how AI fails in 4 critical ways. Understanding how AI fails is essential because these failures don't announce themselves. They compound quietly until they become organizational problems. First, hallucinations. When AI sounds certain and isn't. AI is not a truth engine. It does not retrieve reality. It predicts what is most likely to fit. That means sometimes AI will generate information that sounds plausible but isn't true. Not because it is lying, but because it is producing a best fit response when certainty does not exist in what it can see. In the automotive industry, hallucinations don't appear as harmless errors. They show up as credibility risk and compliance risk. Incorrect warranty coverage explanations, invented policy language or program terms, wrong service procedure recommendations, or helpful advice that violates compliance or brand rules. The danger is not that AI can be wrong. The danger is that it can be wrong confidently, and confidence reads like authority, which is why hallucinations are not a model problem. They are an architectural and oversight problem. They occur when an organization allows probabilistic systems to operate in domains where accuracy must be guaranteed. They are another reason why humans are still critical and their experience still has value. How hallucinations are actually managed. You don't train hallucinations away. You build to expect them. AI must never be allowed to improvise on critical facts. If the answer must be correct, humans must design the system so that correctness is enforced, not hoped for. That requires guardrails. Constrain truth to approved sources. Route answers through vetted knowledge like policies, warranty terms, procedures, and pricing rules. Require traceability by forcing internal citations, references, or source links so the organization can verify what the model is relying on. And escalate uncertainty whenever confidence drops, when data is missing, or when queries cross compliance boundaries. When these situations arise, the system must escalate to a qualified human decision maker, not attempt to proceed. Reader translation: if the AI is guessing, it must not be allowed to guess where accuracy is legally, financially, or reputationally sensitive. The solution is not trust it less. The solution is to architect intelligence so that truth is retrieved, not generated, uncertainty is surfaced, not hidden, and accountability remains explicit. Because in the intelligence age, reliability is not a feature, it is a design decision.
Second, bias. When your organization teaches AI to see the world wrong, AI does not develop bias, it absorbs it. Every model learns from the history you provide and the training data. Every pattern it detects reflects the organization that produced the data. Every prediction it makes is shaped by what your systems were built to notice and what they were never built to see. Which means AI does not just automate decisions, it operationalizes the past. If the past contains uneven treatment, missing perspectives, structural blind spots, or historical shortcuts, AI does not correct them, it scales them. In the automotive industry, this isn't an abstract ethical problem. It shows up as distorted intelligence, lead models that quietly favor specific geographies, demographics, or buyer profiles, service recommendations that reflect years of underserving particular customers, finance interactions that inherit patterns of exclusion, friction, or misclassification. Bias also forms when your organization is simply blind, when data was never captured, or when interactions were never integrated, where context never moved between systems, gaps become assumptions. assumptions become predictions, and predictions become behavior. And because AI learns at machine speed, these distortions propagate faster than human systems ever could. This is why bias is not a data science issue, it is an intelligence architecture issue. It reflects what the organization is structurally capable of seeing. How bias is actually managed. Bias is not corrected by intention, it is corrected by human-led design. By building intelligence systems that enable your teams to measure uneven outcomes across segments, surface where predictions diverge from reality, expose where models were trained on biased data or wrong signals, and continuously reintroduce new context into what the organization sees. This requires human governance, where your team actively tests intelligence, not just models. Your experts diversify learning sources, not just data sets. And your leadership establishes review loops with diverse perspectives that examine how intelligence behaves across the whole customer system, not just inside functions. Because in the intelligence age, bias is not just a social risk, it is a strategic one. It determines whether the organization is building a clearer perception or codifying its own blind spots. Third, drift. When intelligence quietly detaches from reality, AI does not operate in a fixed world. Markets move, customer behavior shifts, vehicle mixes evolve, economic pressure changes decision patterns, and driving habits, ownership cycles, and service needs all drift, which means intelligence trained on yesterday's reality slowly stops matching today's. Not suddenly, but quietly. Performance degrades at the edges first, then in pockets, then systemically. In automotive, drift doesn't appear as apparent failure. It shows up as misalignment, lead models that no longer predict purchase timing accurately, service forecasting that breaks because driving patterns changed, pricing guidance that reflects a market that no longer exists. The systems still work. They're just applying patterns learned from a past the organization is no longer living in. This is not model decay. It is environmental change. And it means AI cannot be deployed and forgotten. It must be maintained as intelligence, which makes drift not a data science issue, but a human monitoring and governance issue. It reflects whether your team has been equipped to notice when reality changes and whether leadership has established processes to retrain AI systems when they do. How drift is actually managed. You don't install intelligence and walk away. Your team operates it continuously, which means intelligent systems require ongoing monitoring, not just of performance, but of relevance, with designated staff responsible for detecting when models drift from reality. This means creating defined intervention thresholds, clear signals for when intelligence must be regrounded rather than merely tuned, and feedback loops from outcomes, so what actually happens reshapes what the system learns. Because without these foundations, intelligence doesn't just age, it detaches. Reader translation: AI is not a project you complete. It is an evolving system that your organization is responsible for, even when it is purchased or outsourced, even when it is embedded inside platforms. If it learns, you own its relevance. And relevance in the intelligence age is architecture.
Fourth, context limits. When tools can't hold the whole story, even strong AI systems can only consider a limited amount of information in one pass. But in automotive, the bigger constraint is usually not the model, it's the application and the size of the databases in the application. Most AI operates within individual tools like CRMs, service platforms, schedulers, chat systems, and pricing engines. Each tool accesses only its own data, customer records, notes, and interpretations. No single tool sees the whole story. So when a customer history is long, a case is complex, or a situation spans multiple departments, the AI isn't failing to hold everything. It was never given the whole story. In automotive, context limits show up as partial intelligence, missing earlier warranty constraints because that knowledge lives somewhere else, forgetting key service notes because they're buried in a different system, misreading multi-step customer situations because the workflow crosses sales, service, parts, and finance, and losing continuity because each tool resets the customer to whatever it can see. The AI responds intelligently to its slice. The problem is organizational fragmentation. What leaders see as AI limitations are often context gaps caused by architecture, the lack of a shared enterprise-wide data foundation that AI can access. You don't fix context gaps by prompting harder. You fix it by designing how data and context are preserved and made accessible across systems. That starts with centralizing underlying data and customer history, so intelligence can retrieve what it needs across systems rather than being trapped inside the tool that happens to receive the question. This is why most organizations begin the architectural journey by building a centralized foundation, often described as a data lake or unified data layer. Not because a lake creates intelligence, but because it allows context to exist in one place. So AI systems can work from a shared record rather than improvising with partial visibility. From there, retrieval, summarization, and escalation patterns are layered on to turn centralized data into usable organizational memory, so intelligence can act with continuity, not guesses. This completes our examination of the 4 critical ways AI fails. Next, we'll explore how data lakes and memory architecture provide the foundation for overcoming these limitations, why context breaks, and how memory fixes it. Context keeps breaking not because AI systems are weak, but because intelligence is being asked to operate across organizations that were never designed to present themselves as a whole. When people hear that AI forgets, they assume it's a model problem. Most of the time, it isn't. It's an architecture problem. Modern AI systems do not operate on your business as a whole. They operate on whatever information is placed inside their field of view at a given moment. That field of view is always finite. An AI system does not know your dealership, your OEM, or your customer base in any comprehensive way. It sees fragments, the records pulled into a workflow, the documents retrieved from storage, the signals streamed in real time. Everything else might as well not exist, which is why context failure shows up inside organizations long before model failure. The intelligence isn't wrong, it's blind. Not because it lacks capability, but because the organization has not yet learned how to present itself to intelligence. And this is where data lakes come into play. Not as an analytics infrastructure, but as the first serious attempt to give AI systems access to organizational memory through intelligent retrieval. At their simplest, data lakes are central repositories where organizations capture and store data in its original form. Not cleaned up for reports, not reduced to dashboards, not forced into yesterday's definitions of what matters. Just recorded, preserved, and made available to intelligence systems. A true data lake is not a reporting database, not a business intelligence layer, not a dashboard engine. It is the place where the whole operational life of the organization is continuously collected and held in machine-readable form.
But this is not a traditional analytics data lake. This is an intelligence foundation. It captures not just quantitative metrics like sales numbers, service times, and inventory counts, but qualitative context such as customer conversations, service notes, advisor observations, and communication threads. It preserves not just isolated data points, but the relationships between them. How a service interaction connects to a purchase decision, how a warranty claim relates to driving patterns, how a customer's financial history informs their life cycle timing. The data is diverse: structured records, unstructured text, images, diagnostic logs, and it's connected by the relationships that reveal how your business actually operates, not just what happened. How intelligence-ready data lakes change everything. Traditional systems are designed around human workflows. Data lakes are designed around machine perception. Their role is to function as institutional memory. They are not optimized for screens. They are optimized for intelligence, artificial intelligence. When an AI system is connected to a properly built data lake, it no longer depends only on what a human happens to paste into a prompt or workflow. It can retrieve relevant history, comparable situations, hidden dependencies, and long-range patterns from across the organization. The AI does not need to hold everything. It only needs to find what matters. This is the architectural move that expands the practical context. The AI's working window remains finite, but the organizational memory behind it becomes vast. Instead of operating on fragments, intelligence systems begin operating on the accumulated experience of the business itself through intelligent retrieval from the data lake. Earlier, warranty clauses become available again. Long-term service patterns re-enter decision-making. Prior diagnostic paths and customer histories stop disappearing between departments. The organization's past becomes accessible to its future. This is what retrieval architectures and data lakes together make possible. This works through retrieval architecture. systems that use semantic search, vector embeddings, or knowledge graphs to find contextually relevant information, not just keyword matches. When a customer calls about a service issue, the AI doesn't search for service issue. It retrieves semantically related patterns, similar customer situations, related warranty history, comparable diagnostic paths, and connected operational context. This is why the data lake must capture relationships, not just records. The connections enable intelligent retrieval, not just database queries. This is how you can better serve that customer and also understand why specific warranty issues recur more frequently than others. The AI works on a small working window. The data lake holds the institutional memory. Intelligence emerges from their relationship.
When memory becomes intelligence. A data lake does not make an organization intelligent. It makes intelligence possible. On its own, a lake is silent. It does not reason, does not decide, does not act. It simply holds the enterprise's accumulated reality. What changes everything is what sits on top of it. When AI systems are connected to institutional memory, they stop operating as isolated features and begin functioning as participants in organizational life. They can retrieve what the organization has lived through, compare current situations to historical patterns, assemble context dynamically, and reason across domains that were never designed to speak. This is the moment intelligence stops being embedded in tools and starts flowing through the enterprise. Instead of answering from whatever a single system contains, intelligence begins to draw from a shared organizational memory. Instead of operating inside applications, it starts to operate across them. This is how context limits are overcome, not by building more innovative models, but by giving intelligence access to the organization itself. Memory is not intelligence, but without memory, intelligence cannot exist. This foundation of organizational memory sets the stage for the next level of AI capability: retrieval architecture and agentic systems that can actively participate in operations rather than simply respond to queries. Retrieval is how intelligence sees. Once institutional memory exists, a new challenge immediately appears. How does intelligence access it? AI does not browse a data lake. It does not wander through systems. It retrieves. Retrieval is the architectural mechanism that determines what intelligence can see, when it can see it, and how meaning is assembled in the moment a decision is being made. This is not a technical detail. It is perception. Retrieval decides whether intelligence operates on fragments or on complete situations, whether it sees transactions or customers, whether it reasons inside departments or across the enterprise, whether it is forced to guess or allowed to know. Through retrieval, intelligence can assemble customer state across sales, service, and ownership, surface historical patterns that mirror current conditions, access governed knowledge rather than improvised answers, and construct situational awareness instead of isolated responses. This is how organizational memory becomes usable, not as storage, but as perception. Without retrieval, a data lake remains inert. With retrieval, the organization becomes visible to its own intelligence. How retrieval actually works in practice. When a customer asks a question or a situation arises, here's what happens in milliseconds. First, the AI converts the question or situation into what's called a semantic representation or embedding, a mathematical pattern that captures meaning, not just keywords. Then this pattern searches the data lake for information that's conceptually similar, not just keyword matches. For example, trade-in interest retrieves customers expressing purchase hesitation, repair cost concerns, and life cycle timing patterns, not just records containing the words trade or interest. Next, the most relevant information is retrieved and assembled into the AI's working memory. Finally, the AI generates recommendations using both its training and your organization's specific retrieved context. This is basic retrieval, already powerful, but still reactive.
Advanced retrieval, agentic systems. Agentic AI systems take retrieval much further by actively managing what they need to know. They determine what information is needed for specific situations, formulate multiple retrieval queries from different angles, and evaluate whether retrieved information is sufficient or requires deeper searching. They can perform multi-step retrieval where initial searches reveal patterns that trigger follow-up searches, ultimately assembling comprehensive situational intelligence. They can use multiple retrieval strategies simultaneously, combining data lake searches with real-time system queries, cross-referencing external data sources when needed, and validating retrieved information against current operational state. As conversations progress, agents retrieve additional relevant context continuously, learning from interaction outcomes to improve future retrieval accuracy and feeding intelligence about what information proved valuable back into retrieval optimization. A real example, service call with agentic intelligence. Let me give you a concrete example. A customer calls and says, "My check engine light came on again." With a basic retrieval system, the AI searches service records for this VIN, returns that the last service was 3 months ago, with the check engine light previously repaired, and the advisor must manually connect dots and decide next steps. But with an agentic retrieval system, something much more sophisticated happens in just 3 to 5 seconds. The agent retrieves complete service history plus warranty status, recognizes the pattern that a similar issue 3 months ago suggests incomplete repair or recurring problem, then retrieves comparable cases across all customers with the same vehicle and issue combination. The system identifies that this pattern in other customers led to transmission replacement 60% of the time. Then it retrieves this customer's financial capacity, current payment status, and vehicle equity position, retrieves their communication preferences and historical satisfaction patterns, and finally assembles complete situational intelligence. This includes diagnostic probability, likely transmission issue requiring $3,500 repair, customer financial context, can afford repair, but recent major expense may trigger trade consideration. Optimal communication approach prefers direct, transparent technical explanations and trade-in opportunity indicators, vehicle equity position favorable, life cycle timing appropriate. All of this happens before the advisor responds. The advisor doesn't see the retrieval process. They see comprehensive situational intelligence that enables consultative conversation instead of information gathering. This is the difference between retrieval and search, between intelligence systems and reporting tools. Traditional systems require humans to be the intelligence layer. Intelligent retrieval makes the organization itself intelligent.
From reactive systems to proactive participants. When intelligence can perceive the organization through a data lake, a second shift begins. It stops waiting to be asked and starts participating. This is where agentic systems enter. An agent is not an interface, not a chatbot, not a single model responding to prompts. An agent is an intelligence role. A system designed to observe conditions, retrieve organizational memory, reason within a defined domain, initiate actions, coordinate with other agents, escalate to humans, and learn from outcomes. The critical distinction is between reactive AI that waits for human prompts, responds to what you ask, returns answers and stops, has no awareness of changing conditions, and requires humans to decide what happens next, versus agentic AI that continuously monitors conditions and patterns, detects situations requiring attention without being asked, takes defined actions within authorized boundaries, maintains awareness of organizational state over time, and determines next steps based on reasoning, not just rules. Here's an automotive example. Traditional service AI operates when a customer calls, AI suggests appointment time, then stops. Agentic service intelligence monitors all vehicles in the service database continuously, detects when a customer's vehicle is approaching warranty expiration with no recent service, retrieves customer communication preferences and service history, identifies optimal contact timing based on similar customer patterns, initiates outreach through their preferred channel, coordinates appointment with technician availability if customer responds positively, schedules follow-up at appropriate intervals if no response, and learns from outcomes to improve future engagement timing, all without human intervention until customer interaction begins. This shift from reactive tools to proactive participants represents the fundamental transformation from AI as software to AI as organizational intelligence. How agentic systems actually operate. Agentic systems have several key capabilities that transform them from tools into organizational participants. They provide continuous environmental monitoring. Agents don't sleep, they observe. They watch real-time operational conditions like technician availability, bay capacity, and parts inventory. They track customer behavior patterns such as service intervals, payment timing, and communication responsiveness. They monitor market signals including seasonal demand, competitive activity, and economic indicators. And they assess system health, watching for workflow bottlenecks, quality issues, and emerging problems. When agents detect situations requiring attention, they perform contextual retrieval intelligence. They formulate retrieval queries based on situational understanding, not keywords. They search across organizational memory for relevant patterns and comparable situations. They assemble comprehensive context from sales, service, finance, and operations. And they prioritize information based on relevance to current decision requirements. Agents apply domain-specific reasoning with specialized expertise. Service agents reason about maintenance timing, repair prioritization, and customer lifecycle indicators. Sales agents evaluate purchase readiness, vehicle fit, and financing feasibility. Operations agents optimize resource allocation, capacity planning, and workflow coordination. Each agent operates with professional-level domain knowledge encoded in their instructions. Within defined boundaries, agents can execute authorized actions. They can initiate customer communications, schedule appointments, and coordinate resources, trigger workflows across systems, generate recommendations, and provide decision support, and update records while maintaining organizational memory. For example, a service agent can schedule routine maintenance appointments automatically, but must escalate warranty-related decisions requiring management approval.
Multi-agent coordination in action. Perhaps most importantly, agents communicate with each other to solve complex situations. Here's a scenario. A customer expresses trade-in interest during a service appointment. The service agent detects the trade signal and retrieves complete service cost history. The sales agent is automatically notified, retrieves purchase history and current inventory, and matches customer preferences. The finance agent evaluates equity position, payment capacity, and optimal timing. All three agents share context and coordinate a unified customer approach. The customer experiences one seamless conversation. Behind it, three specialized intelligences are coordinating in real time. When situations require human judgment, agents recognize escalation needs, uncertainty thresholds when confidence falls below defined levels, high-stakes decisions involving financial commitments above authorization limits, complex emotional situations like customer distress or complaints requiring empathy, and policy exceptions involving situations outside standard operating parameters. When escalating, agents provide humans with complete context, recommended options based on comparable situations, and risk-opportunity analysis, positioning them to make informed decisions quickly. After situations resolve, agents learn from outcomes. They record what actions were taken and outcomes achieved, compare predictions to actual results, adjust future behavior based on what worked, share learning with other agents in their domain, and improve retrieval accuracy based on which information proved most valuable. What this looks like, operationally, a service intelligence agent doesn't just answer questions, it monitors service demand patterns and capacity utilization continuously, detects emerging bottlenecks 3 to 5 days before they affect customer experience, retrieves historical patterns from comparable periods considering weather, seasonality, and local events, initiates proactive customer communications about alternative timing, coordinates technician scheduling based on skill requirements and efficiency patterns, flags exceptions requiring manager attention such as unusual repair patterns or warranty concerns, and learns from resolution outcomes to improve future scheduling and communication. It doesn't live in a screen, it lives in the operation. Staff interact with agents when decisions require human judgment. Otherwise, agents handle continuous coordination, monitoring, and optimization that would consume dozens of hours of human attention daily.
From tools to organizational intelligence. As agents are orchestrated across workflows, intelligence stops being something the organization uses, it becomes something the organization runs on. Automation follows predefined paths, but agents navigate living systems. Automation executes what was designed, but agents reason about what is happening. Automation requires reprogramming for changes, but agents adapt based on learning. And as these agents begin to coordinate across domains, sales, service, operations, finance, compliance, intelligence starts to exhibit organizational behavior. Decisions stop being events and become systems. Coordination stops being meetings and becomes structure. Learning stops being episodic and becomes continuous. This is what intelligence architecture actually builds. Not smarter tools, but organizations capable of perceiving themselves, acting coherently, and evolving over time. This operational transformation sets up the final strategic implications that every automotive leader must understand about intelligence architecture. Why this is an intelligence decision, not an IT decision. Most automotive organizations still treat data as operational exhaust and AI as another software tool to deploy. Data is collected to support reporting requirements, regulatory audits, and compliance documentation. AI is procured to optimize specific functions and improve departmental efficiency. Intelligence architecture inverts both assumptions entirely. In an intelligence-architected organization, data is not a byproduct of transactions. It's the material from which organizational cognition is built. Every customer interaction, service outcome, sales conversation, and operational decision becomes part of institutional memory that agentic systems continuously learn from and retrieve. The critical difference becomes clear when you compare approaches. In the traditional approach, data is stored for compliance and historical reporting. AI tools access their own departmental data repositories. Questions must be formulated by humans who know what to ask, and systems return answers to explicit queries and stop. In the intelligence architecture approach, data is preserved as living organizational memory across all functions. Agentic systems continuously monitor and retrieve from unified memory. Agents formulate their own retrieval queries based on situational understanding, and systems proactively assemble context and initiate action within defined boundaries.
What agentic intelligence requires for success? As we've explained, agents don't wait to be asked. They participate in organizational operations, but participation requires comprehensive awareness. To monitor effectively, agents need continuous access to operational state across departments, not just snapshots when queried. To retrieve intelligently, they need the ability to search organizational memory semantically based on situational patterns, not keyword matching against isolated databases. To reason across domains, they need context that spans sales, service, finance, and operations, the complete customer and operational reality. To coordinate actions, they need shared awareness with other agents, so service intelligence informs sales behavior, inventory patterns shape marketing decisions, and customer lifecycle signals optimize operational planning. To learn continuously, they need persistent memory of outcomes, so agents improve future retrieval, reasoning, and action based on organizational experience. Without unified memory architecture, agentic systems become expensive chatbots, capable of conversation but incapable of the proactive coordination that creates strategic value. A data lake designed for agentic intelligence is fundamentally different from a reporting database. It captures relationships, not just records, showing how service patterns connect to purchase behavior, how financing structures influence long-term loyalty, and how communication preferences correlate with satisfaction outcomes. It preserves context, not just transactions, maintaining conversation threads rather than just final decisions, situational factors rather than just quantitative metrics, and temporal sequences that reveal pattern evolution. It enables semantic retrieval, not just keyword search, so agents find conceptually similar situations rather than exact matches, recognize patterns across different manifestations of the same underlying issue, and transfer learning from one customer type to inform decisions about others. This is built to answer questions your organization doesn't yet know how to formulate, because agentic systems will discover patterns and opportunities humans wouldn't think to search for.
The leadership decisions that shape intelligence. Memory design determines what intelligence your organization can develop through leadership decisions that shape intelligence capability. What gets remembered? Which interactions, patterns, and outcomes are preserved versus discarded? How it's connected? Which relationships across data are maintained to enable cross-domain learning? Who can access it? Which agents and humans have retrieval authority for different intelligence domains? How it's governed? Boundaries on agentic action, escalation protocols, and learning permissions. How it evolves, processes for updating memory architecture as intelligence requirements mature. These are not IT specifications. They are strategic architecture decisions about organizational capability. Context does not scale through better user interfaces. It scales through architecture. And this is why every serious intelligence initiative eventually becomes a memory architecture initiative. Not because data infrastructure is fashionable, but because intelligence without organizational memory is just a sophisticated reaction. And memory, in the intelligence age, is no longer solely a human function. It becomes the substrate on which organizational intelligence operates. and the foundation that determines whether your enterprise can learn, coordinate, and anticipate as a unified system.
Why this technical understanding matters strategically. This chapter wasn't about making you a data engineer or an AI architect. It was about giving you the literacy to recognize what kind of organizational transformation you're actually undertaking. The leaders who will define the automotive intelligence age won't be the ones who deploy the most AI applications. They will be the ones who understand the kinds of systems they're introducing. Not software tools that execute tasks, but agentic systems that observe, reason, and continuously participate in operations. What these systems require to function: unified memory enabling organizational perception, semantic retrieval that assembles situational awareness, and coordination protocols that allow agents to work together rather than operate in isolation. What happens when they're allowed to coordinate? Intelligence moves from departmental silos into enterprise-wide awareness, learning propagates automatically, and the organization begins to anticipate and adapt as a unified system. Once you comprehend the difference between retrieval and search, agents and chatbots, memory architecture and data storage, you can finally see what is actually changing. This is not a technology upgrade cycle. It is a fundamental shift in what enterprises can perceive, how they coordinate, and whether they can learn as unified systems. And the moment intelligence becomes architectural rather than tactical, leadership transforms from deployment management to capability design, from vendor selection to ecosystem orchestration, from measuring AI performance to governing organizational intelligence.
Why Chapter 3 is critical to everything that follows. This chapter serves as the technical foundation that makes every subsequent strategic decision possible. Without understanding what AI actually is, a pattern engine that operates on probability, not truth, leaders cannot make informed choices about governance, boundaries, and architectural design. Without grasping how AI fails through hallucinations, bias, drift, and context limits, executives cannot architect the guardrails, human oversight, and continuous monitoring that intelligent systems require to function safely in automotive environments, where confidently wrong can become compliance disasters or liability events. Without comprehending the difference between basic retrieval and agentic systems, leaders cannot evaluate whether their AI investments will create coordination capabilities or coordination debt. They cannot distinguish between vendors selling sophisticated tools and partners offering intelligence architecture foundations. Most importantly, without understanding that AI systems require unified memory architecture to coordinate effectively, organizations will continue accumulating isolated capabilities that feel productive locally while fragmenting globally. Exactly the coordination debt pattern that prevents intelligence transformation. This chapter provides the literacy that transforms AI from a mysterious technology into a comprehensible organizational capability. It enables leaders to move from hoping their AI investments will somehow coordinate automatically to deliberately designing the conditions under which intelligence can exist as a unified system. Every strategic framework, assessment tool, and implementation decision in the remaining chapters builds on the foundational understanding established here. Without this literacy, the 7-stage maturity framework becomes abstract theory rather than practical guidance. With it, automotive leaders can finally see what they're actually building and design it intentionally rather than accidentally. That's why this chapter exists, not to overwhelm leaders with technical complexity, but to provide the essential literacy that makes intelligence architecture possible. Because in the intelligence age, understanding how these systems work isn't optional technical knowledge. It's strategic capability that determines whether your organization architects competitive advantage or inherits coordination standards set by others.
That concludes Chapter 3 of From the Transactional Age to the Intelligence Age. We've provided the complete technical literacy framework that automotive leaders need to understand AI systems, memory architecture, and agentic intelligence. This foundation enables all the strategic thinking and architectural decisions covered in the remaining chapters.
Welcome back to our audiobook reading of Barry Hillier's From the Transactional Age to the Intelligence Age. We're diving into Chapter 4. Why adding AI tools creates coordination debt, the psychology, economics, and structure behind automotive's AI fragmentation.
This is a pivotal chapter because it explains why so many automotive organizations feel like they're succeeding with AI while actually building structural problems that make their organizations harder to coordinate, not easier. Hillier introduces the concept of coordination debt, which is probably one of the most important ideas in the entire book.
What makes this chapter particularly insightful is that it explains the psychology behind why smart automotive leaders keep making decisions that feel right in the moment but create long-term architectural problems. It's not about competence. It's about applying digital age thinking to intelligence age challenges.
The chapter shows why the approach that built the modern automotive enterprise, evaluate tools, pilot them, measure results, scale what works, actually works against organizations when applied to AI. Let's get into Chapter 4.
Chapter 4. Why adding AI tools creates coordination debt. The psychology, economics, and structure behind automotive's AI fragmentation. There is a moment many automotive organizations experience after AI starts working. A few pilots are live. Vendors are in the market. Dashboards look better. Marketing is more targeted. Sales is more informed. Service is more predictive. On paper, progress is happening. What is actually happening is more specific. The organization is no longer just executing processes. It is beginning to produce judgments, predictions, recommendations, signals, optimizations. Each AI system is not simply automating a task. It is introducing a new point of intelligence into the enterprise. And every new point of intelligence introduces a new point of interpretation, a new version of what the data says, a new view of the customer, a new forecast of what should happen next. This is the structural shift most organizations miss. Digital tools moved information. AI systems generate meaning, and meaning has to be coordinated. Why it feels like progress. At first, adding AI tools feels like progress. Leaders see better insights. Teams feel more informed. Decisions appear more data-driven. But intelligence is contained inside the function where it is deployed as a tool. True intelligence flows into planning, prioritization, resource allocation, and customer experience. And because each AI system learns, optimizes, and reasons locally, the organization begins to accumulate multiple, unaligned intelligences. This is when something quietly changes. Decisions take longer to land. Alignment takes more effort to manufacture. Conversations multiply instead of resolving. Teams leave meetings with more to reconcile, not less. Despite having more intelligence than ever before, the organization becomes harder to steer. Not less busy, less coherent. This moment rarely triggers alarms. It doesn't show up in quarterly reports. It usually arrives when things are already going well, which is why it is so often misread. Leaders assume it's an integration issue, a skills gap, a tooling problem, a normal maturity curve.
In reality, it is something else entirely. It is what happens when intelligence enters structures that were built for transactions, when judgment is produced faster than it can be aligned, when prediction is generated faster than it can be coordinated, when local intelligence expands, but no organizational intelligence can form, because intelligence does not emerge from isolated systems. It emerges from how intelligence is allowed to move, connect, and shape the whole. When AI tools succeed inside organizations that were never designed to hold intelligence, the result is not an intelligent enterprise. It is an enterprise struggling to reconcile intelligence. This is not a technology problem, it is an architectural one, and it is the moment coordination debt begins to form, what coordination debt actually is. Coordination debt is the hidden organizational cost that accumulates when intelligence is introduced through separate tools instead of a shared intelligence architecture. It forms when AI does not become a system. It becomes islands. It is not technical debt. It is not process inefficiency. It is not change resistance. It is the growing burden of trying to make fragmented intelligence behave like a whole. Every AI system creates its own pocket of intelligence. It sees its own data, learns its own patterns, optimizes its own objectives, generates its own version of what should happen next. Each produces signals, predictions, recommendations, priorities, and optimizations. Each of these outputs is a form of judgment. But when those judgments are produced inside isolated tools, platforms, and vendors, they do not accumulate into organizational intelligence. They accumulate into separate points of view, different models of the customer, different interpretations of performance, different forecasts of the future, different definitions of best. Without a shared intelligence architecture, there is nothing that allows these intelligences to reconcile themselves. So that work moves to people. Humans become the coordination layer between machines, and coordination debt forms wherever the organization must increasingly reconcile conflicting intelligence, arbitrate between system outputs, translate meaning across departments, manufacture alignment through meetings, resolve contradictions manually, slow decisions down to reconstruct context. The organization stops scaling intelligence. It scales interpretation. This is the compounding cost of tool-based AI, not license fees, not infrastructure spend, but leadership bandwidth, decision latency, organizational drag, and the quiet erosion of coherence. Coordination debt occurs when intelligence is present everywhere but nowhere allowed to become one. Why does the industry keep buying AI tools? For most of the modern history of the automotive industry, technological progress followed a reliable rhythm. When a function underperformed, a system was introduced. When a process became too complex, software was added. When scale strained human capacity, automation absorbed the pressure. Over time, dealerships, OEMs, and supplier networks became layered environments of specialized platforms, each responsible for making a particular part of the organization faster, cheaper, or more measurable. This reflex didn't just shape IT roadmaps, it shaped leadership culture. Problems were framed in terms of tools, solutions were evaluated by features, progress was demonstrated through implementations. And for a long time, this worked. Digital systems automate transactions. They standardized workflows. They captured information that had once lived only in people's heads. They made operations visible in ways that allowed management, comparison, and optimization. Importantly, they did not demand deep coordination. A CRM could improve sales without understanding service. A service platform could increase throughput without reshaping marketing. A marketing system could optimize campaigns without changing how operations function. Integration was helpful, but rarely existential. The organization could layer systems without restructuring itself. And because this pattern delivered results, it became instinct. So if coordination debt is so corrosive, why does the industry keep moving in this direction?
Because every force-shaping executive decision-making still rewards this reflex. The psychology is familiar. Leaders who successfully navigated previous digital transformations are operating from experience. They watched organizations modernize by layering platforms and improving functions. They saw productivity rise, visibility increase, and margins improve through software adoption. So when AI arrives framed as the next software layer, it naturally enters the same mental category. The market reinforces the interpretation. Most AI products are sold as extensions of existing systems: smarter CRMs, predictive marketing platforms, and intelligent service tools. The messaging is not architectural. It is incremental. It promises an advantage without disruption. The economics stabilize the pattern. Individual AI tools can be scoped, piloted, given owners, justified, measured, forecast. They fit neatly inside existing procurement and governance processes. The financial logic of buying another system is familiar. The financial logic of redesigning organizational intelligence is not. The CFO is far better equipped to evaluate a single-point AI solution than to underwrite an architectural shift that lacks a historical template. Even the optics align. A portfolio of AI initiatives looks like momentum. A roadmap of pilots looks like innovation. A slide showing adoption across departments reassures boards that something is happening, which means most organizations do not choose coordination debt. They finance it, not because they misunderstand technology, but because they are applying the only transformation logic that has ever reliably worked. Why the largest organizations will find it harder to break coordination debt. The paradox of the current moment is that the organizations with the most resources are often the least able to move first. Large automotive enterprises carry immense operational responsibility. Dealer networks, manufacturing schedules, financing systems, compliance regimes, and customer service infrastructures cannot pause while intelligence is redesigned. Stability is not optional. Revenue cannot dip. Safety margins cannot narrow. Regulatory exposure cannot expand. AI intelligence architecture, however, requires foundational change. It requires unifying data access. It requires redefining how systems learn. It requires deciding where the coordination authority lives. It requires shifting from platform ownership to intelligent stewardship. For established automotive organizations, for OEMs, large dealer groups, and enterprise operators, every architectural decision touches dozens of dependent systems. Every attempt to unify intelligence risks destabilizing processes that currently work. Dealer operations, OEM logistics, finance, compliance, service delivery, these environments are not empty canvases. They are living systems. This is why, organizationally, the safer path is almost always to extend rather than rebuild. Add intelligence to what already exists. Attach AI to familiar workflows. Let each function modernize on its own terms. And this is the point most organizations miss. AI initiatives don't behave like past technology programs. These are not additive projects. They are reconstructive ones.
The last time automotive faced this kind of shift, it wasn't solved by buying better tools. Henry Ford did not add machinery to craft production. He rebuilt production around a new organizing principle. The digital age was not won by installing computers into paperwork. It was won by rebuilding operations around information flows, transaction systems, and connectivity. The intelligence age carries the same requirement. You do not add intelligence to an organization designed for transactions. You reconstruct the organization around how intelligence moves. For an organization, that kind of reconstruction is not just technical, it is operational, political, cultural. Every architectural move ripples outward. Every step toward unified intelligence puts pressure on systems that currently work well enough to protect. So, large organizations accumulate AI instead. They layer tools where they can, they localize impact, they contain risk. Over time, this produces impressive pockets of intelligence inside an organization that becomes harder to integrate as a whole. Smaller, younger, and structurally lighter competitors are not carrying the same weight. They are not constrained by legacy architectures, political seams, or fragmented data estates. At least not to the same extent. They can design intelligence first and wrap operations around it. They can treat coordination as a foundational capability rather than a patch. And they can build learning systems that span functions, precisely because there are fewer historical boundaries left to cross. This asymmetry matters, not because size stops mattering, but because the source of advantage is changing. In previous eras, advantage scaled with physical reach, capital efficiency, and operational throughput. In the intelligence age, it increasingly scales with architecture, with how well an organization's systems learn together, reason together, and act as one. And intelligence cannot be bolted on one tool at a time.
That concludes Chapter 4 of From the Transactional Age to the Intelligence Age. Hillier has explained one of the most important concepts in the book, coordination debt. This is the hidden cost that accumulates when organizations add AI tools without architectural thinking.
The key insight is that coordination debt isn't a failure. It's the predictable result of applying digital age transformation logic to intelligence age systems. Every force in the automotive industry still rewards the tool-by-tool approach that worked for previous technology waves, even though it creates structural problems with AI.
What makes this chapter particularly valuable is that it explains why smart automotive leaders keep making decisions that feel right but create long-term problems. It's not about competence. It's about using the wrong framework for a fundamentally different kind of technology transformation.
The chapter also explains why large automotive organizations will find it harder to break coordination debt than smaller, more agile competitors. This creates a strategic asymmetry where advantage increasingly comes from intelligence architecture rather than operational scale.
In our next session, we'll continue with Chapter 5, From Tools to Intelligence, where Hillier introduces the 7-stage maturity framework that shows how organizations can move from tool accumulation to true intelligence architecture.
It's a crucial chapter because it provides the roadmap for breaking coordination debt and building the systematic intelligence capabilities that create sustainable competitive advantage.
Welcome back to our audiobook reading of Barry Hillier's From the Transactional Age to the Intelligence Age. We're diving into Chapter 5, From Tools to Intelligence. This is where Hillier provides the roadmap for breaking coordination debt and building true organizational intelligence.
This is one of the most practical chapters in the book because it introduces the 7-stage intelligence maturity framework. After 4 chapters of diagnosis and explanation, this is where Hillier shows automotive leaders exactly how organizations move from accumulating AI tools to building systematic intelligence architecture.
What makes this framework particularly valuable is that it's developmental, not just descriptive. Each stage builds the capabilities that the next stage requires. You can't skip stages, which explains why so many organizations get stuck at stage 3, using AI functionally, but never achieving true organizational intelligence.
The critical inflection point sits between stage 3 and stage 4. Below that line, AI improves departments. Above it, AI begins to change what the organization itself can become. Let's explore this framework.
Chapter 5. From Tools to Intelligence. If coordination debt is the disease, architecture is the cure. The response to coordination debt is not better integration. It is not better tooling. It is not more disciplined deployment. It is architecture. Coordination debt does not form because organizations make poor choices. It forms because intelligence has outgrown the structures built to contain it. Systems can now learn. They can predict. They can generate judgment. But the organization they operate inside is still structured to route transactions, not intelligence. Which means every new AI capability increases both insight and organizational strain. The way forward, then, is not to optimize the deployment of intelligence. It is to redesign the conditions under which intelligence is allowed to exist, how it is produced, how it is remembered, how it moves, how it shapes behavior beyond the systems that generate it. Tools are not the problem. The absence of coordination architecture is. This is the shift from using AI to building intelligence. And that shift changes the role of leadership. Because when intelligence becomes something an organization must hold rather than just apply, the primary responsibility of leaders can no longer be selection. It becomes design, not of tools, of the organizational foundations that determine whether intelligence can compound or only collide. This is the work of intelligence architecture, and it is now unavoidable. The intelligence pyramid. What actually has to be built? Most automotive organizations today are somewhere between experimentation and functional deployment. AI is present. Value is being created. But the form that value takes determines whether it compounds or fragments. The framework that follows reflects 7 recognizable states organizations move through as they shift from AI usage to AI intelligence. Not as a checklist, as a developmental path. Each stage produces capabilities the next stage depends on. Skip them, and advanced AI investments collapse into coordination chaos rather than intelligence gains. The critical inflection sits between functional intelligence and unified intelligence. Level 4. Below it, AI improves departments. It is a tool-based organization. Above it, AI begins to change what the organization itself can be. It becomes an intelligence organization.
Stage 1, individual AI usage. Every intelligence transformation begins personally. At this stage, AI enters the organization through people, not systems. Advisors experiment with writing assistants. Managers test analysis tools. Marketers explore creative generation. A few technically curious employees begin using AI to make sense of information that once overwhelmed them. In a progressive dealership, a service advisor may discover that AI helps them translate complex mechanical issues into language customers understand. A parts manager may uncover seasonal patterns they've never been able to articulate before. A sales professional may find that AI surfaces questions they didn't know how to ask. The value here is not efficiency, it is familiarity. This stage quietly rewires fear into fluency. It allows people to experience AI as an augmentation rather than a replacement. Without it, every higher-order initiative becomes a change management failure. But these gains remain isolated. Insight improves. The organization does not, which is why this stage always produces the same next realization. If this is useful for one person, it should be built into the work. Stage 2. AI inside processes. Here, AI moves from personal productivity into operational flow. Lead scoring appears inside the CRM. Scheduling optimization enters the service lane. Inventory forecasting augments parts planning. Reporting tools are beginning to generate interpretations rather than summaries. Each system improves measurable performance. Response times shorten, waste declines, decisions improve. This stage is often where organizations feel they are doing AI. And they are. But only inside the logic of the digital age. Each AI capability strengthens a workflow. Each delivers a return. Each is evaluated on its own success. What also begins to surface here, often subtly, are the seams, sales intelligence that doesn't account for service history, marketing optimization that ignores delivery capacity, forecasts that don't agree, recommendations that collide. At first, this friction appears to be a data problem. It is not. It is the first signal that intelligence is trying to exceed the boundaries of the processes in which it has been placed. Stage 3, functional intelligence and the coordination ceiling. At this stage, departments stop using AI as a tool for assistance and start operating through it. Sales systems predict conversion probabilities, recommend pricing ranges, and optimize follow-up strategies. Service intelligence anticipates maintenance demand, manages bay utilization, and coordinates technician skills. Marketing systems dynamically orchestrate personalization, channel mix, and spend allocation. Each function becomes, in a very real sense, intelligent, performance improves dramatically, and so does complexity, because now each department is no longer just executing work. It is generating interpretations, forecasts, strategic signals. Each is optimizing toward its own success metrics, using its own learning loops inside its own operational context.
This is where most organizations now find themselves, and this is where the experience of progress quietly changes. Leadership meetings become harder to resolve. More insights arrive than can be reconciled. Systems disagree. Committees multiply. Dashboards grow. Decision cycles stretch. Nothing is broken. Everything is busy. This is the coordination ceiling, the point at which adding intelligence increases organizational friction faster than it increases organizational clarity. The organization has intelligent parts. It does not yet have intelligence as a system. Breaking through this ceiling requires a shift most organizations underestimate, not better integration, a different architecture. Stage 4, unified intelligence, the real transition. This is the stage no automotive organization has realized yet, but many are now circling. 2026 will be the year that pioneers redefine the industry for the years and decades to come and break through stage 4. This is where intelligence crosses the entire dealership and breaks down department silos. Unified intelligence begins when AI systems stop operating as departmental assets and start functioning as a shared cognitive layer across the enterprise. Customer context is no longer owned by marketing, sales, or service. It becomes organizational. Learning is no longer local. It becomes cumulative. Optimization no longer happens inside silos. It happens across outcomes. In a unified intelligence environment, a customer is never handed off. They are continuously understood. Their service history informs their purchase experience. Their purchase behavior reshapes service engagement. Their financial profile influences marketing treatment. Their lifecycle value shapes operational decisions. The systems do not just exchange data. They operate from the same situational awareness. This is where AI stops improving processes and starts changing what the organization can do. Decisions compress. Experiences smooth. Strategy becomes adaptive rather than reactive. And for the first time, the organization behaves more intelligently than any of its departments. This is the architectural break. Everything below this stage can be built through tools. Everything above it must be built through design. Stage 5, network intelligence, when learning starts to scale. Unified intelligence changes what a single dealership or operation can do. Network intelligence changes what an organization can become. This stage occurs when AI no longer belongs to a single location, rooftop, or management team. Intelligence begins to move across the organization itself. In a dealer group environment, this is the moment when learning stops being local. What works in one market doesn't remain trapped there. What fails in one store prevents it from happening elsewhere. Customer behavior patterns discovered in Toronto quietly reshape inventory strategies in Calgary. Seasonal service trends in one region alter staffing models across the group. The organization starts to behave less like a collection of businesses and more like a single learning system. The difference is subtle, but profound. Performance improvement no longer depends on training sessions, internal memos, or quarterly reviews. It propagates automatically. Experience becomes infrastructure.
For leadership teams, this is often the first time intelligence feels like an asset rather than an output. Not reports, not dashboards, but a system that remembers. Network intelligence creates a new kind of advantage, one that cannot be replicated by deploying better tools at individual sites, because the advantage does not live inside the tools. It lives in the way the organization accumulates understanding. This is also where the gap between unified organizations and fragmented ones begins to widen quickly. Groups that reach this stage start compounding. Those who don't are forced to relearn the same lessons in parallel. Stage 6, ecosystem intelligence. When organizations start thinking together, network intelligence changes the organization. Ecosystem intelligence changes the industry. This stage begins when intelligence is no longer confined inside enterprise boundaries, when learning, prediction, and coordination extend into the relationships that define how automotive actually operates. OEMs, dealer groups, suppliers, logistics partners, finance providers, and service networks. At this level, AI systems are no longer just optimizing internal operations. They are interpreting signals across the value chain. Dealer demand informs production before shortages appear. Warranty patterns reshape engineering priorities. Financing behavior alters inventory flows. Service intelligence influences design. Marketing signals reshape distribution. This is not data exchange. It is shared situational awareness. When ecosystem intelligence emerges, coordination no longer relies primarily on contracts, forecasts, and quarterly reviews. It happens continuously through systems that adapt as conditions shift. This is the point where industry power begins to reorganize. Organizations capable of participating at this level do not just execute better, they also achieve greater results. They become structurally more valuable to every partner they touch. They shape standards, they influence platforms, they attract preferential relationships. Those who cannot coordinate at this layer become dependent on those who can. Not because they lack technology, but because they lack coherence. Stage 7, autonomous intelligence, when adaptation becomes continuous. Autonomous intelligence is not about removing people from the organization. It is about removing the delay. At this stage, large portions of operational coordination no longer wait for human orchestration. Systems manage flows, balance constraints, detect weak signals, resolve conflicts, adjust strategies within defined boundaries. Inventory rebalances itself. Staffing models shift with demand. Customer journeys reorganize dynamically. Pricing is based on lifetime value, not transactions. Human leadership does not disappear here. It moves from managing operations to shaping objectives, from resolving conflicts to designing conditions, from directing activity to governing intelligence. This is the stage where organizations stop running systems and start stewarding them. It is also the stage where advantage becomes extraordinarily difficult to challenge, because what competes is no longer execution speed or even decision quality. It is learning velocity, and learning systems do not stand still. Why these stages cannot be skipped. What these later stages make clear is why AI transformation cannot be compressed into tool programs. Each stage requires structural conditions the previous one creates. You cannot scale intelligence across a network that has not unified it locally. You cannot participate in ecosystem intelligence without internal coherence. You cannot introduce autonomy into systems that cannot already coordinate. When organizations attempt to jump these layers, they don't fail loudly. They stall. They accumulate pilots. They multiply vendors. They add dashboards. They form AI committees. And underneath it all, the same coordination burden continues to grow. The framework strategy exists to prevent that outcome, not by slowing adoption, by sequencing capability.
Why this chapter matters. Up to this point in the book, we've been examining history, patterns, and the structural tensions quietly forming across the industry. This chapter is where those ideas stop being abstract. The maturity framework is not a theory of what AI could become. It is a map of what automotive organizations are already becoming. Every dealership group, OEM, supplier, and platform company now finds itself somewhere on this curve, whether it has language for it or not. Most organizations today are operating below stage 4. They are using AI to assist individuals, enhance processes, and, in some cases, introduce intelligence into departments. These efforts are not wrong. They are necessary, but they are not sufficient. What this framework makes visible is that the real shift does not occur when better tools are deployed. It occurs when intelligence stops living inside functions and begins shaping the organization itself. The difference between stage 3 and stage 4 is not technical. It is architectural. It is the moment when AI stops being something your teams use and becomes something your enterprise is built around. Everything below that line eventually plateaus. Everything above it compounds because network intelligence, ecosystem intelligence, and ultimately autonomous intelligence are not capabilities that can be purchased or added later. They are organizational capacities that only emerge when earlier foundations exist. They cannot be installed. They can only be grown. From this point forward, organizations will still invest. They will still experiment. They will still pilot, deploy, discard, and redesign. But the direction of their compounding will diverge. Some will compound toward architecture. Their mistakes will strengthen foundations. Their learning will accumulate. Their intelligence will begin to move. Others will compound toward complexity. Their investments will increase the coordination load. Their capabilities will fragment. Their leadership layers will thicken. Both paths will produce impressive technology. Only one produces intelligence. And once that divergence takes hold, it does not show up first in products or platforms. It shows up in what organizations can become. That concludes Chapter 5 of From the Transactional Age to the Intelligence Age. Hillier has provided the roadmap that shows how organizations move from AI tool accumulation to systematic intelligence architecture through 7 developmental stages.
The key insight is that these stages can't be skipped. Each one builds the capabilities that the next stage requires. Most organizations today are stuck at stage 3, where departments are intelligent, but the organization as a whole isn't yet. The breakthrough to stage 4, unified intelligence, is the architectural crossing that changes everything.
What makes this framework particularly powerful is that it explains why so many AI initiatives stall. Organizations try to jump to advanced capabilities without building the foundational stages. They accumulate coordination debt instead of developing intelligence architecture.
The framework also shows why this is ultimately about organizational transformation, not just technology deployment. The later stages, network intelligence, ecosystem intelligence, and autonomous intelligence, represent fundamentally different organizational capabilities that create sustainable competitive advantages.
In our next session, we'll continue with Chapter 6, The Executive Paradox, Managing AI, where Hillier explores why the leaders who built digital age success often find it hardest to lead intelligence age transformations.
It's a crucial chapter for understanding the human side of this transformation and why successful executives often need to evolve their leadership approaches for the intelligence age. Thanks for listening.
Welcome back to our audiobook reading of Barry Hillier's From the Transactional Age to the Intelligence Age. We're diving into Chapter 6, The Executive Paradox, Managing AI. Why the leaders who built digital age success find it hard to do it again in an intelligence age transformation.
This is one of the most personally challenging chapters in the book because Hillier directly addresses the C-suite executives who are reading it. He makes the uncomfortable argument that the biggest obstacle to intelligence transformation might be the very success patterns that got these leaders to where they are today.
What makes this chapter particularly important is that it's not about competence or vision. It's about how the skills, instincts, and decision patterns that built digital age success now work against leaders in the intelligence age. The approaches that scale the modern automotive enterprise now quietly prevent it from becoming intelligence architected.
Hillier introduces the concept of go slow to go fast for intelligence age leadership, where deliberate foundational work accelerates long-term competitive advantage more effectively than rapid tactical implementation. Let's explore this executive paradox.
Chapter 6, The Executive Paradox, Managing AI. Let's start with an uncomfortable truth. Most C-level executives will never say publicly, the biggest obstacle to your organization's intelligence transformation may be you. Not because you're doing anything wrong, because you're doing what you were trained to do. The skills, instincts, and decision patterns that built success in the transactional and digital ages push leaders toward tools, platforms, pilots, and performance metrics. Those instincts worked. They scaled the modern automotive enterprise. And now, in an intelligence era, they quietly work against it. This chapter isn't about competence or vision. It's about success, creating blind spots. Your career was built by mastering the rules of digital age competition. You learned how to evaluate technology investments, manage implementation projects, measure ROI, and drive organizational change. You brought discipline to complexity. You delivered results that shareholders and stakeholders could trust. Those skills got you to the C-suite, and they've likely served your organization well for years. But now you're sitting in strategy meetings, hearing phrases like AI intelligence architecture, 7-stage frameworks, and coordination debt, and something inside you resists. Not because you don't understand the concepts intellectually, but because they challenge the assumptions that made you successful. And the resistance feels rational. You catch yourself asking, why do we need to rebuild our technology architecture when our current systems work? Why invest in speculative intelligence capabilities when we can buy AI tools with measurable ROI? Why risk disrupting operations that deliver consistent results? Why change approaches that have made us successful for decades? These aren't wrong questions. They're the right questions for the competitive environment that shaped your expertise. The problem is that the competitive environment is shifting beneath you while you're still optimizing for it. The strategic philosophy: go slow to go fast. Before we explore how leadership must evolve, we need to address the tension you're already feeling between urgency and prudence. There are options where you don't need to jump into uncertainty to make the right decisions. The automotive industry is experiencing what strategists call a go slow to go fast moment, where deliberate foundational work accelerates long-term competitive advantage more effectively than rapid tactical implementation. You can feel the pressure. You hear it in board meetings and leadership calls. We need AI now. Competitors are implementing AI. Board members are asking about AI strategy. We can't afford to fall behind. The wisdom of going slow is that taking time to architect intelligence capabilities systematically creates sustainable competitive advantages that tactical AI implementations cannot deliver. But there's also a danger on the other side. While you're deliberating, pioneering competitors are building intelligence architecture that will establish industry standards you'll spend years trying to match. What makes this moment uniquely difficult is that we are still at the beginning. There is no widely accepted automotive playbook for intelligence architecture yet. No settled patterns, no safe sequence of moves, no vendor bundle that magically turns into enterprise-wide intelligence. You may want them, but they don't exist, at least not yet.
The methodologies are still being discovered in real time, and the organizations willing to learn in public through early architecture bets, controlled experiments, and operational discipline are effectively writing the transformation playbooks the rest of the industry will borrow. That's why 2026 matters. This is the period when the first repeatable approaches will be proven, packaged, and taught by the companies that chose to pioneer rather than wait for certainty. The balance is the whole point. Move deliberately on foundation building and architectural decisions, but move decisively once strategic direction is established. This is not hesitation dressed up as strategy. It's the leadership discipline required for a different kind of transformation, one where the winners aren't just adopting what exists, but helping define what the future looks like. Why your risk management instincts need calibration. Traditional technology transformations rewarded speed. You could move quickly on individual implementations since integration challenges could be addressed later. Most digital systems created value in isolation. Architecture mattered, but it wasn't the primary constraint. Execution was. Intelligence age transformation is different. Moving fast on individual AI tools without architectural thinking creates coordination debt that prevents advanced intelligence capabilities from working. Architecture must come first, but once it exists, it enables rapid capability development because you're no longer trying to stitch together intelligence after the fact. That's the strategic insight. The executives who invest time in understanding intelligence requirements and designing systematic architecture will ultimately move faster than those who rush into implementation without coordinated planning. You may feel like you have to act, but it is more important that you think and plan. The emotional reality of leading through uncertainty. This transformation is emotionally challenging for successful executives, and it's rarely discussed honestly in strategy sessions. There's a competence threat where intelligence age leadership requires learning new approaches, which means temporarily feeling less expert than you're used to. There's a legacy concern about whether the approaches that made you successful will become obsolete, and whether embracing intelligence age leadership invalidates your professional expertise. There's a responsibility weight where, as CEO, COO, CFO, CTO, or CIO, your decisions affect hundreds or thousands of employees, and the stakes feel higher when you're pioneering rather than following proven approaches. There's board pressure where stakeholders expect you to demonstrate AI leadership you don't feel you have, while maintaining operational performance and financial results. And there's the pioneer's loneliness where you're making decisions without established industry best practices to reference. These concerns are valid and normal. Every generation of executives has faced technological shifts that required them to expand their expertise. The difference now is recognizing that your experience provides the foundation for intelligence age leadership. It doesn't disqualify you from it. You also need to remember that your competition feels the exact same way right now. How each C-suite role must evolve. Research shows that 86% of CFOs cite limitations in technology, such as legacy systems, aging ERPs, and fragmented architecture, as impediments to AI deployment. Yet many of these same organizations continue approving individual AI tool implementations rather than intelligence architecture investments. This isn't irrational, it's the logical result of risk management frameworks designed for digital age technology adoption. Digital age risk management minimized implementation risk by starting small, proving value, and scaling successful approaches. That worked because digital tools created value independently before integration became necessary. Intelligence age requirements are different. Architecture must be designed for coordination from the beginning because AI creates value through learning and coordination, not just individual processing capability.
The CEO's intelligence age evolution. For CEOs, the strategic reframe involves moving from market positioning to intelligence positioning. The mindset shift isn't how do we compete more effectively? It becomes how do we build the capability to compete in ways that weren't possible before? The evolution happens in phases. Initially, CEOs need to frame AI intelligence as competitive infrastructure, not departmental tools. Position intelligence development as a strategic priority alongside operational performance and market growth. Create executive accountability for intelligence coordination rather than isolated AI projects. The critical decision phase requires making the CEO-only decision. Commit to systematic intelligence development or remain in tactical tool accumulation. Decide whether to invest in architecture that requires 18 to 30-month cycles and align expectations accordingly. The leadership phase involves leading strategy that includes organizational learning capabilities alongside market analysis, making decisions based on intelligence recommendations rather than just periodic reports, and positioning the organization for ecosystem relationships as an intelligence leader. The challenges don't disappear, they sharpen. CEOs must manage board expectations, stay grounded in current market realities, and lead through uncertainty without losing confidence. The CFO's investment strategy evolution. For CFOs, the financial reframe becomes ROI through learning capabilities that compound over time. The mindset shift moves from what's the ROI on this tool to how does this investment build capabilities that compound advantage? The development process begins with building analysis that captures intelligence value, not just efficiency, while including coordination cost and fragmentation overhead explicitly. The strategy phase involves budgeting for multi-year infrastructure and compound returns while evaluating vendors through coordination and learning architecture, not feature lists. The leadership phase requires tracking returns from predictive capability and coordination advantage while educating stakeholders that intelligence ROI follows a different curve than traditional technology investments. The CTO's architecture evolution. For CTOs, the technical reframe moves from systems that process to systems that learn and coordinate. The mindset shifts from what do we implement to what infrastructure enables organizational learning and coordination. The assessment phase involves evaluating whether AI systems can share context and coordinate decisions, not just exchange data. The development phase requires architecting for real-time sharing, coordination platforms, and security and reliability for learning systems. The operational phase means operating adaptive systems that continuously improve without compromising stability, which requires different technical leadership skills than managing static infrastructure. The CIO's information evolution. For CIOs, the information reframe treats data as a coordination capability, not just storage and reporting. The mindset shift moves from how do we manage data to how do we enable intelligence coordination through information architecture. This evolution begins with assessing whether AI can access comprehensive context in real time and whether data quality meets learning requirements. The architecture phase involves designing systems for shared context, governance for coordination, and security that enables learning without loss of control. The leadership phase requires running information architecture that supports predictive intelligence and coordination, not just historical reporting, which fundamentally changes how information leadership operates.
The team coordination imperative. The most important point is simple. AI intelligence development requires coordinated evolution across the C-suite. If each leader adapts individually, you still end up with fragmentation. If the executive team adapts collectively, you create architecture-level coherence. This means going slow together on intelligence architecture decisions, alignment on objectives and timelines, readiness and change planning, and risk mitigation. Then going fast together on implementation, decision-making, resource allocation, and performance optimization once coordination is operational. Concrete disciplines matter: monthly alignment sessions, quarterly architecture reviews, unified board communication, and a clear approach to measurement during transition. The executive team must learn to operate as a coordinated intelligence leadership system, not just a collection of functional experts. The professional stakes of pioneer leadership. The 7-stage framework provides the roadmap, but executive success requires acknowledging that intelligence age leadership builds on rather than replaces digital age expertise. If you continue current approaches, you may appear to be leading AI adoption while hindering intelligence development, creating sophisticated capabilities that increase coordination challenges, customer inconsistency, and strategic complexity. If you pioneer intelligence architecture, you build systematic AI intelligence, and your leadership approach becomes part of the standard that the industry will later follow. That leaves a professional question that's difficult but clarifying. Will your legacy be efficient management of digital age systems during an intelligence age transition, or will it be pioneer leadership that help define the next standard of competition? The path from resistance to pioneer leadership requires each C-level executive to expand their proven capabilities rather than abandon them. This isn't an invitation to become a different kind of leader. It's a requirement to lead the next era with the same discipline that made you successful in the last one, applied to a different set of constraints. The organizations that recognize this evolution requirement and invest in coordinated C-suite development alongside intelligence architecture will be the ones that successfully cross from managing AI tools to governing organizational intelligence.
Welcome back to our audiobook reading of Barry Hillier's From the Transactional Age to the Intelligence Age. We're diving into Chapter 7, The Human Architecture Problem: Why Intelligence Fails Inside Organizations That Cannot Hold It.
This is one of the most important chapters in the book because it addresses the uncomfortable reality that 70% of AI initiatives fail, not because of technology problems, but because of human and organizational factors. After 6 chapters focused on technical and strategic aspects, this chapter confronts the human side of intelligence transformation.
What makes this chapter particularly challenging is that it examines why organizations that successfully implement AI tools often struggle with the human architecture needed to support intelligence coordination. It's not enough to have smart systems. You need people and organizational structures capable of working alongside intelligence.
Hillier explores the generational dynamics, cultural forces, and organizational psychology that determine whether AI becomes a force multiplier or a coordination burden. Let's explore why human architecture is actually intelligence architecture.
Chapter 7: The Human Architecture Problem. Up to this point, this book has focused on what is structurally changing, how artificial intelligence evolved, why coordination, not capability, is now the limiting factor, how coordination debt forms, what intelligence architecture actually requires, where the architectural crossing truly happens. What has been deliberately left until now is the most difficult part, the part no diagram solves, the part no platform fixes, the part no vendor can carry for you: people. Because every intelligence architecture is built inside a human architecture, and every organization in existence today was designed in a world where artificial intelligence did not exist. Intelligence had to live in people. Judgment, memory, and coordination could only be human. Organizations were constructed around that constraint. They were never designed to support intelligence as an artificial system-level capability. That historical reality matters, because it means AI is not entering neutral environments. It is entering structures optimized for a world in which intelligence could only exist within human roles, processes, and hierarchies. And those structures do not automatically accommodate intelligence that learns, predicts, and coordinates on its own. The 70% failure reality. There is emerging research across major institutions like BCG and MIT that should permanently change how leaders interpret AI transformation. Roughly 70% of AI initiatives fail for reasons unrelated to the technology. Not because the models underperform, not because the tools don't work, not because the data scientists aren't capable. They fail because people are not equipped to live alongside intelligence that learns, predicts, and acts. They fail because asking someone to trust a system that knows their customer better than they do feels like professional erasure. They fail because middle managers discover that AI exposes every inefficiency they've spent years learning to navigate around, and suddenly their hard-won expertise feels obsolete. They fail because frontline employees realize the AI is surfacing patterns they missed, and instead of feeling supported, they feel surveilled. They fail because executives approve AI initiatives expecting improved efficiency, but instead face something much more unsettling: organizational transparency they never prepared for. When AI shows that the sales process consistently breaks down at the same 3 predictable points, it's not just revealing operational friction, it's revealing that leadership has been managing around problems instead of solving them. When AI demonstrates that customer satisfaction correlates more strongly with response timing than with individual service quality, it doesn't just suggest process improvement, it questions the entire performance management system. When AI reveals that the best sales outcomes come from conversations that don't follow the approved methodology, it creates an impossible choice between bureaucratic compliance and results. This is why AI initiatives fail at the human level, not because people resist technology, because intelligence makes organizational denial unsustainable. And most organizations in the automotive industry are not designed for that level of honesty. They are designed to execute transactions, manage functions, and coordinate people, not to host intelligence as a living system that continuously reveals what actually works, what doesn't, and why. So AI initiatives rarely fail at the algorithm. They fail at the organization's willingness to be seen by its own systems. The training crisis behind the failures. The uncomfortable truth behind that 70% failure rate is simple. Most organizations are implementing AI faster than they're developing AI literacy. They're installing intelligent systems into workforces that have never been taught how to work alongside intelligence. This isn't a technology problem, it's a training crisis. AI literacy is not about learning to code or understanding machine learning algorithms. It's about developing the specific skills needed to work effectively with systems that learn, predict, and recommend.
In automotive, AI literacy means knowing when to trust an AI recommendation and when to override it, understanding what data the AI is seeing and what it's missing, recognizing when AI patterns don't account for real-world factors like weather, local events, or customer emotions, being able to teach AI systems through feedback so they improve over time, and maintaining professional judgment while leveraging AI insights. Without this literacy, AI becomes either blindly trusted or reflexively rejected, neither of which produces intelligence. For decades, automotive technology followed a predictable pattern. Humans learned the system, then executed through it. DMS training meant learning the screens and following the workflow. CRM training meant entering the data and running the reports. Digital tools training meant mastering the interface and optimizing the process. AI doesn't work this way. AI systems adapt, learn, and change their behavior based on outcomes. They make recommendations that need to be interpreted, not just executed. They surface patterns that require professional judgment to evaluate. This means the training challenge has fundamentally shifted from how do I use this tool correctly to how do I work with this intelligent system effectively. Why traditional training fails with AI. Most AI failures happen because people default to extreme responses, either over-reliance where they think the AI said it, so it must be right, resulting in following recommendations that don't account for context the AI can't see, or underutilization where they think, I don't trust it, so I'll do it my way, resulting in expensive AI systems that become glorified reporting tools. Both responses happen because people weren't trained to be AI literate partners. They weren't taught how to collaborate with intelligence, how to combine their expertise with AI capabilities to produce outcomes neither could achieve alone. Most organizations approach AI training the same way they approached previous technology training: vendor demonstrations, feature overviews, best practices documentation, and here's how to use the new system. This approach assumes the system is static. AI systems are not. They evolve based on data, feedback, and usage patterns. What works today may not work next month. What the AI recommends for one customer type may not apply to another. Effective AI training must teach people how to work with adaptive systems, not static tools. The three-part literacy framework. Successful automotive AI training focuses on three core competencies that work together to create effective human-AI collaboration. Interpretive skills involve learning how to read AI recommendations in context, when to question the data behind AI decisions, and how to spot when AI assumptions don't match reality. This isn't about becoming a data scientist. It's about developing the judgment to evaluate AI outputs professionally. Collaborative skills focus on how to combine human expertise with AI insights effectively, when to override AI recommendations, and how to do it productively, and how to provide feedback that improves AI performance over time. This creates a partnership dynamic rather than a replacement dynamic. Adaptive skills teach how to adjust working methods as AI systems evolve, how to maintain professional judgment while leveraging AI capabilities, and how to teach AI systems through real-world experience. This ensures that human expertise guides AI development rather than being displaced by it. Without systematic development of these skills, AI implementations plateau at basic automation rather than evolving into organizational intelligence. You can buy the most sophisticated AI platforms available, but if your people don't have the literacy to direct, challenge, and collaborate with those systems effectively, you've purchased expensive confusion. The competitive advantage in the intelligence age won't go to organizations with the most advanced AI. It will go to organizations with the highest AI literacy, because AI literacy determines whether intelligence systems become force multipliers or coordination burdens. The generational challenge. Walk into any dealership group today, and you will find 4 different professional generations working side by side. They share the same showrooms, service drives, and meeting rooms, but they often carry very different relationships to technology, authority, and change. AI does not arrive in a neutral environment. It lands inside those generational stories.
For many veteran automotive professionals, those who are boomers and built their careers before digital systems were central, AI doesn't register as innovation first. It registers as a threat to visibility. Their value has always lived in what they know, what they've seen, and what they can recognize that others miss. The fear is not that machines will replace them, it is that the depth they carry will become harder to see, easier to overlook, and less central to how the organization works. They worry about becoming background knowledge in a foreground system. They have spent decades being the person people turn to. Any technology that seems to flatten that status or move insight out of people and into platforms touches something far deeper than workflow. For this group, human transformation succeeds only when AI clearly magnifies their standing, when it makes their experience with customers more powerful, their influence in decision-making more influential, and their visibility across the organization more visible. For Generation X, those who came up modernizing dealerships through DMS rollouts, CRM adoption, digital marketing, and consolidation, the tension is different. They are not unsettled by technology. They built their careers implementing it. What AI destabilizes is not comfort, but control. They learned leadership through managing systems, optimizing departments, and driving performance through structure. Intelligent systems change the nature of that work. Influence no longer flows only through reporting lines. Coordination happens across boundaries. Decisions are shaped by models and signals as much as by meetings. The shift is from supervising execution to directing intelligence. That requires a new form of authority, less about approving actions, more about shaping environments in which actions emerge. For Gen X leaders, the challenge is not adopting AI, but redefining leadership when the organization itself becomes a sensing system. For millennials, many now in mid-career management and senior contributor roles, AI represents neither threat nor disruption. It represents separation. They are fluent in digital systems. They adapt quickly. They expect tools to evolve. What differentiates them is not whether they can use AI, but whether they can rise above it. This is the cohort where intelligence fluency becomes leadership capital. The ones who learn to think systemically, to coordinate across functions, to translate intelligence into strategy, begin to separate themselves from peers who simply operate tools. For this generation, AI raises questions about trajectory. Am I becoming more capable or merely more efficient? More strategic or simply faster? Their relationship to AI will shape the next layer of executive leadership in automotive. For the youngest professionals entering the industry as Generation Z, AI is not an event. It is the environment. They arrive comfortable with intelligent systems, automation, and constant software change. What they lack is not technical ease. It is industry grounding. They have not yet built the pattern recognition, customer instincts, mechanical intuition, and situational judgment that automotive excellence is made of. Their risk is not resistance. It is superficiality. They can move quickly inside intelligent systems without yet knowing what deserves attention. They can surface insights before they fully understand their meaning. For them, human transformation is about pairing digital fluency with craft, so that AI accelerates the development of real expertise instead of substituting for it. This is why AI transformation in automotive is never just technological, it is generational. It asks veterans to re-express mastery, asks Gen X leaders to re-author leadership, gives millennials a new ladder of differentiation, and demands that Gen Z earn depth, not just speed. Human transformation succeeds when each group encounters AI not as erasure, but as elevation. When experience becomes more influential, not less. When leadership becomes more strategic, not more distant. When ambition becomes systemic, not individual. When digital fluency becomes grounded in real-world judgment. The cultural forces that shape AI success. Automotive is not just another business sector implementing AI. It's an industry built on cultural foundations that create both the strongest opportunities for AI success and the most dangerous blind spots that must be addressed.
The commission culture reality, let me be blunt. Many in the industry live from deal to deal. When you tell a salesperson that AI will improve long-term customer relationships, their immediate thought is, will this help me close the deal I'm working on right now because my mortgage is due Friday? This urgency creates incredible hustle, adaptability, and creative problem solving. Good salespeople can read a customer in 30 seconds and adjust their approach on the fly. Service advisors can juggle 6 customers simultaneously while managing technician schedules. This real-time decision-making under pressure is valuable. But commission pressure also drives short-term thinking that can hurt customers and business. The advisor who recommends unnecessary services because they need to hit a bonus. The salesperson who doesn't mention the better fit vehicle because this one pays more. The parts manager who pushes high-margin items over customer needs. AI reveals uncomfortable truths that your top grossing salesperson might have the worst customer retention, that the advisor hitting targets is creating warranty claims, that short term wins are creating long term losses. The cultural tension becomes this AI is going to tell management I'm not performing even though I'm hustling every day. The solution is showing them immediately how AI helps them make more money. Not theoretically, not eventually, but today. This AI tool shows you which service customers are most likely to trade in the next 90 days. That's commission opportunities sitting in your service drive right now. Make it about their success, not company efficiency. The Tribal Knowledge Challenge. Automotive has an apprenticeship culture. New people learn by watching veterans. The problem? They're learning 2008 techniques in a 2026 market. This is how we've always done it isn't wisdom. It's often just inertia. Mentorship creates deep institutional knowledge, the veteran who remembers that one customer interaction that teaches volumes, the service manager who understands the seasonal rhythms of the local market. This contextual knowledge is real and valuable. But tribal knowledge often means bad practices get passed down like tradition. Always push extended warranties on every deal. Never quote prices over the phone. Service customers are just service customers. They won't buy. These weren't best practices. They were survival tactics that became doctrine. AI reveals that the proven techniques that worked when gas was $2 per gallon and inventory was plentiful don't work when customer expectations, shopping behavior, and market dynamics have fundamentally changed. The cultural tension becomes, this computer is telling me my mentor who trained me and made me who I am was wrong. The solution is honoring the relationship while evolving the practice. Mike taught you to read customer body language. That skill is still valuable. AI helps you use that reading to match them with the right vehicle faster based on patterns from 10,000 similar customers. Frame it as building on what veterans taught, not replacing it. The departmental silo problem. Dealerships are kingdoms within kingdoms. Sales doesn't talk to service. Service doesn't trust parts. F&I operates independently. BDC is its own island. Everyone protects their territory, their commission structure, and their way of doing things. Specialization creates expertise. Sales focuses on closing. Service focuses on throughput. Parts focus on inventory. Everyone masters their domain. But these silos destroy customer experience. The customer who buys from Sarah in sales will never hear from Sarah again. Their service advisor has no idea about the purchase experience. When they're ready to trade, sales treats them like a fresh lead. The customer experiences 3 different companies, not one dealership. AI reveals how much money is being left on the table because departments don't coordinate. Service customers who should be in the sales pipeline. Sales customers whose poor service experience kills loyalty. Parts opportunities missed because service doesn't communicate customer needs. The cultural tension becomes, if service starts getting credit for sales leads, my commission gets smaller. If sales starts calling my service customers, they're poaching my CSI scores. The solution is showing how coordination expands the pie rather than dividing it differently. When service identifies trade-in opportunities, you're not splitting commissions. You're creating deals that wouldn't exist otherwise.
The trust and surveillance concern. Most automotive professionals have learned that when management gets better data, it means tighter monitoring, harder quotas, and more criticism. Transparency means they can see everything you're doing wrong. This creates self-reliance. Good people learn to perform without hand-holding. They develop thick skin, they get results despite obstacles, but it also creates hiding behavior. People learn to game metrics, avoid documentation, and keep information to themselves. If I tell management about this problem, they'll blame me for it. AI reveals everything, every conversation, every decision, every outcome. And people know it. The cultural tension becomes, this AI is just big brother surveillance that management will use to micromanage me or prove I should be fired. The solution requires rebuilding trust first before AI can work. This AI system is for your use to help you perform better. Management doesn't get individual activity reports. They get aggregate patterns. When AI shows a problem, we're solving the problem, not blaming the person who surfaced it. Be transparent about what data is collected, who sees it, and how it's used. No surprises. The transformation fatigue factor. Automotive professionals have heard it all. This CRM will change everything. Digital retailing is the future. Social media will revolutionize sales. Mobile first will transform customer experience. Most of these transformations meant more work, more systems, more complexity, and maybe 5% improvement. This skepticism prevents chasing every shiny object. It forces vendors to prove value. It protects against disruption for disruption's sake. But it also creates cynical resistance to changes that genuinely matter. This is just another thing that will be gone in 18 months, so I'll just wait it out. Veteran skeptics are often right. Most revolutionary initiatives fail because they don't solve real operational problems. They just create new reporting requirements. But the survivor's pattern recognition, which correctly identified past fads, sometimes misses genuine improvements because they've learned to assume all change is just management theater. The cultural tension becomes, I'll nod and smile in the meeting, but I'm not changing how I actually work until I see if this sticks. The solution is proving this isn't management theater by solving their actual daily problems first. This isn't another dashboard for management to watch you. This tool eliminates the 3 phone calls you make every morning to check inventory status. Show immediate operational relief, not strategic transformation promises. The technology adoption spectrum. The final cultural force is the wide spectrum of technology comfort across the workforce. Some people embrace new tools eagerly, others resist any change, and most fall somewhere in between. AI amplifies these differences because it requires more active collaboration than previous technologies. The solution isn't forcing everyone to the same comfort level, it's designing AI systems that work with the existing spectrum while gradually expanding everyone's capability. Some staff will become AI power users who push the boundaries of what's possible. Others will use AI for basic assistance while maintaining traditional approaches. Both can be valuable if the systems are designed to accommodate different collaboration styles. The unspoken fears. Beneath every AI rollout live questions that never make it into steering committees, but they should be addressed. Will this make me easier to replace? Will customers still need me? Will my judgment still matter? Will performance become harder to distinguish? Will my income change? Will I lose control of my work? These fears don't disappear through messaging. They disappear through experience. When people find themselves more prepared in customer conversations, when they resolve problems faster and more thoroughly, when customers trust them more, not less, when their professional standing rises rather than flattens. Organizations that cross that threshold don't manage resistance. They outgrow it. From adoption to organizational identity. The deepest shift in an AI transformation is the moment an organization stops talking about what it is implementing and starts recognizing what it is becoming. Not a dealership with AI tools, but an intelligent dealership. Not a group that runs systems, but a group that operates with shared awareness. Not a business that reacts faster, but one that anticipates earlier. At that point, AI stops being a project. It becomes part of the organization's identity. How people prepare, how they collaborate, how they decide, how they learn, how they compete. That shift is not technical. It is human. Why human architecture is intelligence. Architecture. Technology diffuses. Data strategies converge. Vendors improve. Features equalize. But organizations that learn how to think, lead, and coordinate inside intelligent systems develop something far harder to replicate. They attract stronger people. They retain experience. They coordinate faster. They sense earlier. They evolve continuously. They don't just run better operations. They become learning organizations inside a sensing environment. And that is where durable advantage now lives. The strategic reality of human transformation. Everything covered in this chapter, the 70% failure rate, the training crisis, the cultural forces, the generational differences, points to one central truth. Human architecture is intelligence architecture. You cannot build systems that learn faster than your people can adapt. You cannot coordinate intelligence across departments that don't trust each other. You cannot scale AI beyond what your culture can absorb. This is not a change management problem to be solved after technology deployment. This is the foundation that determines whether intelligence architecture works at all. The automotive organizations that succeed in the intelligence age will not be those with the most sophisticated AI systems. They will be the ones that redesign how people and intelligence work together, where AI amplifies cultural strengths while addressing cultural blind spots, where generational differences become collaborative advantages, and where human expertise guides rather than resists artificial intelligence. Your technical architecture can coordinate data. Only your human architecture can coordinate meaning. The most successful intelligence transformations happen when organizations recognize that the human side isn't a constraint to be managed. It's the architecture that enables intelligence to flourish. The organizations that invest in systematic AI literacy development alongside technology deployment that address cultural forces directly rather than hoping they resolve themselves, and that treat generational differences as collaboration opportunities rather than resistance problems will be the ones that actually cross from using AI tools to becoming intelligent enterprises. The rest will continue to struggle with coordination debt, wondering why their AI investments aren't delivering the transformation they expected. Not because the technology isn't working, but because the human architecture wasn't designed to support it. This is why human transformation becomes the architecture that determines whether intelligent systems create sustainable competitive advantage or sophisticated coordination overhead. Welcome back to our audiobook reading of Barry Hillier's From the Transactional Age to the Intelligence Age. We're diving into Chapter 8, When Success Masks the Real Problem. This is where Hillier confronts the most uncomfortable reality in AI transformation. Organizations can feel successful while building toward fragmentation instead of intelligence.
This chapter hits particularly hard because it's about that moment when your AI initiatives are showing progress, your dashboards look great, and your departments are reporting wins. But something feels heavier rather than lighter. It's success that doesn't feel sustainable, and Hillier explains exactly why this happens.
What makes this chapter crucial is that it shows how the metrics we use to prove AI success are often the same metrics that hide intelligence failure. Organizations can be measuring AI activity while missing intelligence capability entirely.
After 7 chapters building understanding of coordination debt, human architecture, and the challenges of intelligence transformation, this is where Hillier forces the uncomfortable assessment. Are you building toward intelligence, or are you just getting really good at sophisticated fragmentation?
Chapter 8. When Success Masks the Real Problem. There is a moment in almost every automotive executive's AI journey when something uncomfortable happens. Not failure, success that doesn't feel sustainable. It usually doesn't happen during vendor demos or board presentations. It happens later, when the dashboards show progress, when departments report wins, when the organization is undeniably doing more with AI than ever before. And yet, something feels heavier rather than lighter. After completing Chapter 8's analysis of human architecture, this feeling makes perfect sense. You now understand that 70% of AI failures happen at the organizational level, not the technical level. You recognize that automotive culture creates specific resistance points that must be addressed through generational training strategies. You see how commission culture, tribal knowledge, turf wars, trust deficits, and survivor mentality all shape AI adoption success. But understanding the problem and solving it are different challenges. Most organizations discover that implementing human architecture is harder than implementing technical architecture because people don't upgrade as systems do. The uncomfortable realization that surfaces at this stage: your AI tools are working exactly as designed. Your departments are showing measurable improvement, but your people are still doing most of the coordination work manually. Sales AI identifies opportunities, but salespeople still call the service to check availability. Service AI optimizes scheduling, but service advisors still hunt across systems for customer context. Finance AI structures deals, but finance managers still manually reconcile recommendations with sales and service. You have intelligent systems inside an organization that still think like separate departments. This is not a technology problem. This is the predictable outcome of deploying intelligence faster than developing intelligence literacy. And it's exactly why most automotive organizations today aren't failing at AI. They're misreading the kind of progress they're actually making. The question that defines this chapter: are you building toward organizational intelligence, or are you building sophisticated fragmentation that requires more human coordination, not less? The synthesis: why you feel successful building the wrong thing. Everything in the previous 8 chapters explains exactly why automotive organizations feel confident about their AI progress while quietly building toward fragmentation instead of intelligence. You learned that automotive has successfully navigated 3 major coordination shifts by layering new technologies onto existing structures. That historical success makes the current tool accumulation approach feel familiar and safe. You discovered that AI literacy requires different skills than traditional technology adoption, but most organizations are still using digital age training approaches. This creates the illusion that AI training is happening when actual intelligence coordination skills aren't being developed. You saw how coordination debt forms when intelligent systems operate without architectural design, but coordination debt accumulates slowly and invisibly. So it feels like maturity rather than dysfunction. You understand that most organizations are stuck at stage 3, functional intelligence, achieving departmental wins while missing the architectural crossing to stage 4. Stage 3 success metrics make it feel like you're succeeding at AI when you're actually plateauing below intelligence. You recognize that executive instincts trained by digital age success actively work against intelligence age requirements. This means leadership teams can feel strategically competent while making architecturally limiting decisions. You learned that 5 cultural forces in the automotive industry create specific resistance to intelligence coordination, but the same forces make tool-based AI feel culturally acceptable. Your culture rewards exactly the approach that prevents intelligence architecture. Here's the uncomfortable synthesis. Every chapter in this book explains why your current AI approach feels successful, looks progressive, and appears strategically sound, while quietly ensuring you'll never achieve organizational intelligence. You're not failing at AI. You're succeeding at the wrong version of it.
The measurement trap that hides architectural failure. The metrics you're using to prove AI success are the same metrics that hide intelligence failure. Digital age, success metrics, departmental performance improvement, ROI on individual AI implementations, user adoption rates, process efficiency gains, cost reduction achievements, intelligence age success metrics, cross-departmental learning propagation, coordination friction reduction, human AI collaboration quality, organizational anticipation capability, customer experience coherence. The problem? You're measuring the first list and missing the second one entirely. This creates a dangerous confidence gap. Your dashboards show AI success while your organization quietly accumulates coordination debt. Performance improves locally while systemic intelligence fragments. The questions your current metrics cannot answer. When service discovers a customer insight, does sales automatically benefit? When AI identifies a pattern in one location, does learning spread across your network? Are your people getting better at directing AI systems or just better at using AI tools? Do complex customer situations get resolved faster or do they just get broken into more efficient pieces? Most organizations discover they're measuring AI activity instead of intelligence capability. They're counting implementations instead of coordination. They're tracking adoption instead of architecture. They're celebrating efficiency instead of evolution. And every success metric confirms they're on the right track, right up until the moment they hit the coordination ceiling and realize they've built sophisticated fragmentation instead of systematic intelligence. Your current AI investments are not the problem. Architecture is. The problem is not what you've built, it's that these capabilities are operating on fragments of organizational reality instead of the whole. The technical reality: your AI tools are intelligent, but they're likely blind to most of your organization. Each AI system sees only what it contains, but none of them sees the customer as a whole. When a customer calls to coordinate a trade-in with their service schedule, your AI tools cannot do so because they don't share organizational memory. They're operating on fragments, not intelligence. The missing technical foundation, data lakes, as discussed in Chapter 4, functions as your organization's master memory, continuously capturing information from every system, DMS, CRM, service platforms, part systems, finance tools, and storing it where AI systems can access the complete operational picture. Strategic framework, from tool optimization to intelligence coordination. Keep and connect strong AI tools through data architecture. upgrade tools to intelligence-ready systems, replace AI tools that cannot access shared organizational memory, implement retrieval architectures that allow AI systems to find relevant context dynamically, deploy agentic systems that can coordinate decisions rather than just make recommendations, build the technical foundation for intelligence architecture, data lake implementation, create an organizational memory that all AI systems can access. Retrieval systems enable AI to find relevant patterns and context dynamically. Coordination protocols allow AI systems to share learning and coordinate decisions. Agentic workflows deploy AI systems that participate in operations rather than just advise. The strategic insight: most organizations have more intelligence architecture than they think. They just need to connect it to shared organizational memory and honestly assess their people, training, culture, systems, and tools.
3 technical layers that enable intelligence architecture. Understanding the technical foundations that enable intelligence coordination helps executives make strategic decisions about which current investments can be leveraged and which need to be replaced. 3 coordination capabilities that enable intelligence architecture. Layer 1, shared memory foundation, the shared context layer. What it is: organizational memory that allows AI systems to access shared context across departments. This could be implemented through data lakes, connected databases, real-time streams, or distributed memory systems that function as unified organizational memory. Why it matters: AI systems cannot coordinate without shared context. When each AI tool sees only its departmental slice, intelligence remains fragmented, regardless of how sophisticated individual tools become. Current investment impact: most existing AI tools can connect to unified memory architectures without replacement, dramatically expanding their effective intelligence by giving them access to patterns that only emerge across departments. Layer 2, dynamic context assembly: how memory becomes useful. What it is: the capability for AI systems to dynamically find and assemble relevant organizational memory when making decisions. This is a function of Layer 1, not separate infrastructure. Why it matters: AI systems can only consider limited information at once, but dynamic context assembly lets them access whatever organizational memory is relevant to specific decisions in real time. Current investment impact: existing AI tools become dramatically more capable when they can access relevant history, comparable situations, and cross-departmental patterns, rather than operating on isolated data fragments. Layer 3, proactive intelligence coordination, listen and act. What it is: AI systems that observe organizational conditions, coordinate with other AI systems, and take action based on data changes, moving from reactive tools that respond to prompts to proactive systems that participate in operations. Why it matters: this transforms AI tools into organizational intelligence that can sense changes, coordinate responses, and learn from outcomes automatically rather than waiting for human direction. Current investment impact: some existing AI tools can be enhanced into responsive coordination systems. Others need to be replaced with intelligence-ready alternatives that can participate in workflows rather than just provide recommendations. Strategic assessment for current AI investments. For each current system, can this system access and contribute to shared organizational memory? Layer 1. Can this system dynamically find and use relevant context? Layer 2. Can the system detect organizational changes and automatically coordinate responses? Layer 3. All 3 capabilities. Build intelligence architecture around these foundations. 2 capabilities. Enhance missing coordination capabilities, 1 or none. Replace with intelligence-ready alternatives during renewal cycles. The goal is not to eliminate current investments, it's to evaluate which ones can contribute to systematic intelligence and which ones will always require manual coordination.
From assessment to intelligence architecture, the strategic implementation path. Based on assessment results, organizations can now design implementation strategies that preserve current value while building systematic intelligence capability. If your current AI investments can coordinate, build intelligence architecture around them. If your current AI investments cannot coordinate, connect them to the technical foundations from Chapter 4, data lakes, retrieval architecture, and coordination protocols. If your current AI investments prevent coordination, replace them during renewal cycles with intelligence-ready alternatives. The implementation reality. Most automotive organizations will find they have a mix of all three categories. The strategy is not complex. Preserve what coordinates, connect what can coordinate, and replace what prevents coordination. This means the path forward is evolutionary, not revolutionary. Keep the AI tools that deliver value and can share intelligence. Build the data architecture that allows coordination, as described in Chapter 4. Develop the AI literacy that enables human-AI coordination, as outlined in Chapter 8. Replace isolated tools gradually as they come up for renewal. The strategic advantage goes to organizations that can make this transition while maintaining current operational performance. Because once the coordination foundation exists, every AI capability becomes more valuable, and every new AI investment strengthens the system rather than fragments it. This is how you move from accumulating AI tools to building organizational intelligence, not by starting over, but by connecting what you have to the architectural foundation that makes intelligence possible. From understanding to honest assessment. Everything in this chapter points to one critical realization. Understanding why you feel successful while building toward fragmentation is not the same as knowing where you actually stand. This chapter showed you why your success metrics can hide coordination debt, how current investments can be leveraged within an intelligence architecture. Why does technical progress without human architecture create sophisticated fragmentation? How to preserve operational value while building systematic capability. But understanding the framework and honestly assessing your organization against it are different challenges. And the transition every organization must make from we're succeeding at AI adoption to are we building toward intelligence or just accumulating sophisticated tools? This transition requires something most executives find uncomfortable, honest self-assessment that might destabilize the story of progress. Because once you understand the difference between tool accumulation and intelligence architecture, you cannot avoid the harder question, which one are you actually building? The organizations that can answer this question honestly, while foundations are still forming, will be the ones that architect competitive advantage rather than inherit it. The organizations that avoid this question will make the choice by default, usually in ways that preserve current comfort while preventing future transformation.
That concludes Chapter 8 of From the Transactional Age to the Intelligence Age. Hillier has confronted the most uncomfortable reality in AI transformation. Organizations can feel completely successful while building sophisticated fragmentation instead of intelligence coordination.
The key insight is that the metrics we use to measure AI success, departmental improvements, tool adoption, efficiency gains, often hide the architectural failures that prevent true intelligence coordination. Success at the wrong level can mask structural problems that compound over time.
What makes this chapter particularly valuable is the practical assessment framework for evaluating current AI investments. Most organizations discover they have more intelligence architecture potential than they realized. They just need to connect existing capabilities to shared organizational memory.
The chapter emphasizes that understanding the problem and honestly assessing your position are different challenges. Organizations must transition from celebrating AI adoption to critically evaluating whether they're building toward intelligence or accumulating coordination debt.
In our next session, we'll continue with Chapter 9, The Mirror Test, where Hillier provides the tools for honest organizational assessment and shows how to determine where you really stand on the intelligence maturity framework.
It's a crucial chapter because it moves from diagnosis to specific assessment, helping automotive leaders understand exactly where they are so they can design where they need to go.
Welcome back to our audiobook reading of Barry Hillier's From the Transactional Age to the Intelligence Age. We're diving into Chapter 9, The Mirror Test. Where are you really on AI intelligence? This is where theory meets reality, and Hillier provides the tools for honest organizational assessment.
This chapter is particularly challenging because it forces automotive leaders to move beyond the comfort of progress narratives and confront the hard question: are you building toward intelligence architecture, or are you just accumulating sophisticated tools that require more coordination, not less?
What makes this chapter crucial is that it provides the assessment framework that determines strategic direction. After 8 chapters of building understanding, this is where leaders must honestly evaluate where they stand before they can design where they're going.
The chapter introduces what Hillier calls the assessment question that defines everything, a single diagnostic that reveals whether you've built toward intelligence coordination or accumulated coordination debt. Let's explore this mirror test.
Chapter 9. The Mirror Test. Where are you really on AI intelligence? The hard part isn't the answer. It's asking the question. Most leadership teams don't avoid assessment because they are afraid of what they'll find. They avoid it because assessment destabilizes the story of progress. And by this point in the journey, progress is real. AI tools are deployed. Use cases are live. Dashboards are richer. Operations are more automated. Teams are more informed. From the outside, and often from the inside, the organization appears to be moving forward, which is exactly why this moment is so difficult. As Chapter 9 revealed, the success metrics you're using to measure AI progress may be hiding the architectural problems that prevent intelligence coordination. Assessment becomes difficult not because you're failing, but because you might be succeeding at the wrong thing. This is why the transition from Stage 3 to Stage 4 is most often delayed and misdiagnosed. Below that line, AI improves functions. Above it, intelligence reshapes the organization. But from the surface, both look like progress, and progress hides architecture. You may see faster response times, higher appointment rates, improved service efficiency, cleaner reporting, more consistent workflows. By every digital age measure, the investments are paying off. And yet, as you saw in Chapter 5, another signal often appears at the same time. Not failure, friction, handoffs that still feel manual, systems that still disagree, meetings that increasingly exist to reconcile intelligence, an organization that feels more automated but not more coherent. This is the lived experience of operating with intelligence inside transactional structures. It is what coordination debt feels like before it is named. And it is why honest assessment becomes the central act of leadership at this stage of the journey. Not to count tools, not to catalog pilots, but to understand what kind of organization your current architecture is actually producing. Because you cannot cross into intelligence architecture by adding momentum. You cross it by design. And you cannot design that crossing from where you hope you are, only from where you actually stand. You need to know where you are before you can design where you're going. The assessment question that defines everything. By this point in your AI journey, you don't need another explanation of what unified intelligence looks like. You need to answer one honest question. When a customer brings a situation that spans sales, service, and finance, what actually happens in your organization? Not what your systems are capable of theoretically. Not what your best people can accomplish with effort. What happens automatically? The answer reveals whether you've built toward intelligence architecture or accumulated coordination debt, regardless of how impressive your individual AI implementations appear. Assessment reality, unified intelligence. Complex situations resolve where they arise with full context automatically assembled. Functional intelligence. Complex situations require human coordination between smart departments. That's the only assessment that matters. Because everything else, ROI metrics, adoption rates, performance improvements, can be achieved through tool accumulation that never becomes organizational intelligence.
Where are you in the automotive intelligence pyramid? When an organization crosses from Stage 3, functional intelligence, to Stage 4, unified intelligence, it doesn't simply get better, it enters different competitive physics. The Stage 4 advantage: what organizations actually gain: speed without complexity, decisions compress because context is automatically assembled, leaders spend time on strategy rather than information reconciliation. Learning that scales. What service discovers immediately reshapes sales behavior. Insights propagate through the system rather than through meetings and memos. Customer experience coherence. Customers feel understood across all touchpoints. Loyalty builds around systematic intelligence rather than individual relationships. Anticipatory operations. Problems are identified before they surface. Opportunities are spotted before competitors see them. Strategy becomes proactive rather than reactive. Strategic guidance. Why this crossing cannot be delayed. The architectural reality. Once workflows, data structures, and vendor relationships harden around stage 3, departmental intelligence crossing to stage 4 becomes exponentially harder. Current investments become constraints. Systems optimized for local performance resist coordination. Vendor contracts designed for departmental ownership prevent shared intelligence. Staff trained on isolated tools struggle to coordinate across functions. This is why assessment timing matters strategically. Organizations that recognize they're at stage 3, while foundations are still flexible, can redesign around unified intelligence. Organizations that discover coordination limitations after years of stage 3 optimization must unwind accumulated architectural decisions while maintaining operational performance. The competitive implication: stage 4 organizations don't compete on better tools, they compete on systematic intelligence that stage 3 organizations cannot replicate through individual improvements, which means the assessment question determines more than current position. It determines whether you will architect competitive advantage or inherit standards set by others. Why crossing to stage 4 determines your future. Stage 5, when internal intelligence becomes external market advantage. Here's what happens when organizations achieve unified intelligence, stage 4, and then scale it across networks. Stage 5, your internal coordination becomes your market differentiation. The seamless intelligence that customers experience inside your organization becomes the standard they expect everywhere else. When other dealerships feel fragmented in comparison, customer expectations reset around intelligence coordination rather than individual service quality. Your learning velocity becomes your competitive moat. Network intelligence means that what you learn on one rooftop immediately improves performance in another. Seasonal patterns, customer preferences, and operational improvements propagate automatically across locations. Competitors must still transfer learning through training sessions and best practice memos. Your ecosystem relationships become architectural advantages. OEMs, suppliers, and partners begin aligning with your intelligence capabilities rather than just your business volume. Your coordination capability makes you more valuable to work with, creating preferential access to inventory, programs, and partnerships. Why this makes stage 4 assessment urgent. Organizations that reach stage 5 early set the coordination standards that others must adapt to. They don't just compete better, they change what customers expect, what partners require, and what competition looks like. But stage 5 is only accessible through stage 4. You cannot coordinate intelligence across networks until you can coordinate intelligence within your own organization. This is why the assessment question is strategically critical. If you're building towards stage 4 unified intelligence, stage 5 becomes achievable as a natural progression. If you're accumulating stage 3 capabilities, functional intelligence, stage 5 remains structurally impossible, regardless of how many AI tools you deploy. The competitive implication: organizations that achieve stage 5 coordination don't compete against individual dealerships. They compete against the entire market's expectations. And once market expectations are reset around intelligence coordination, individual excellence, no matter how strong, begins to feel insufficient to customers who have experienced systematic intelligence. This is why assessment timing determines strategic positioning, not just operational improvement. Why stage 5 is the strategic prize.
Why this chapter matters. Because the most dangerous position in an intelligence transition is not being behind. It is being confident and misaligned. Organizations rarely fail at adoption. They fail at diagnosis. They measure activity instead of architecture, tools instead of systems, momentum instead of position. They optimize motion without knowing what they are actually becoming. This chapter exists to slow you down at exactly the right moment, before investments harden into structures, before experiments quietly become architecture, before early advantages calcify into permanent constraints, not to tell you where you should be, but to make sure you understand clearly and honestly where you are. Because in the intelligence age, awareness is not reflection, it is design, and what you are becoming is already being built. But individual organizational intelligence doesn't exist in isolation. The ecosystem your organization operates within, OEMs, dealer networks, suppliers, is also making architectural choices that will determine whether your intelligence coordination efforts lead to competitive advantage or coordination dependency. The next chapter examines how those ecosystem dynamics are already reshaping where power sits in automotive intelligence, and why the center of the industry may be shifting faster than many realize. That concludes Chapter 9 of From the Transactional Age to the Intelligence Age. Hillier has provided the mirror test that every automotive organization must face. Honest assessment of whether they're building intelligence architecture or accumulating coordination debt.
The key insight is the assessment question that defines everything. When a customer brings a situation that spans sales, service, and finance, what actually happens automatically in your organization? This single question reveals whether you've achieved unified intelligence or are still operating with intelligent departments that require human coordination.
What makes this chapter particularly valuable is that it shows why timing matters strategically. Organizations that recognize they're at stage 3 while foundations are still flexible can redesign for unified intelligence. Those who discover coordination limitations after years of stage 3 optimization face much harder architectural reconstruction.
The chapter also reveals why stage 4 is the critical threshold that determines future competitive positioning. Organizations that cross to unified intelligence can progress to network and ecosystem intelligence. Those that remain at functional intelligence hit permanent coordination ceilings.
In our next session, we'll continue with Chapter 10. Why OEMs are part of your intelligence architecture story, where Hillier explores how ecosystem dynamics are reshaping power in the automotive industry, and why individual intelligence coordination efforts must account for ecosystem realities.
It's a crucial chapter for understanding how dealer-OEM relationships are evolving in the intelligence age and why coordination partnerships will determine competitive positioning.
Welcome back to our audiobook reading of Barry Hillier's From the Transactional Age to the Intelligence Age. We're diving into Chapter 10. Why OEMs are part of your intelligence architecture story. This chapter shifts the focus from individual organizational assessment to ecosystem dynamics and how they shape competitive positioning.
This is a fascinating chapter because it explores how the intelligence coordination decisions happening at every level of the automotive ecosystem, dealers, OEMs, suppliers, either reinforce each other towards systematic intelligence or fragment into competing coordination systems that require manual reconciliation.
What makes this chapter particularly important is that it shows how your organizational intelligence assessment from Chapter 9 exists within a larger ecosystem reality. The architectural choices OEMs make about intelligence sharing and coordination will directly impact whether dealer intelligence efforts lead to competitive advantage or coordination dependency.
Hillier introduces some uncomfortable questions about who's really architecting automotive coordination in the intelligence age. Is it still the OEMs, or are dealer groups and technology companies beginning to set the standards that manufacturers must adapt to? Let's explore this ecosystem transformation.
Chapter 10. Why OEMs are part of your intelligence architecture story. Your organizational assessment from Chapter 9 exists within a larger reality. Every participant in the automotive ecosystem, dealers, OEMs, suppliers, service networks, is making the same architectural choice between intelligence coordination and tool accumulation. The ecosystem either evolves together towards systematic intelligence or it fragments into competing coordination systems that require manual reconciliation. Here's the ecosystem reality. OEMs possess vehicle intelligence, engineering data, and production planning capabilities that no dealer network can replicate. Dealer groups possess customer intelligence, local market knowledge, and service coordination capabilities that no OEM can match. Suppliers possess parts intelligence, logistics coordination, and network optimization capabilities that neither dealers nor OEMs can build independently. When these intelligence capabilities coordinate as an ecosystem, they create advantages that isolated intelligence, no matter how sophisticated, cannot achieve. But when each participant builds intelligence in isolation, the entire ecosystem operates through manual coordination between intelligent systems. This affects your organizational strategy directly. The decisions OEMs make about intelligence sharing Ecosystem coordination and architectural openness will determine whether your organizational intelligence becomes more valuable over time or gets constrained by ecosystem fragmentation. What follows is not about OEM strategy versus dealer strategy. It's about understanding how ecosystem intelligence emerges when all participants design for coordination rather than control. Because the automotive ecosystem either becomes intelligently coordinated or it becomes a collection of sophisticated silos that customers, employees, and partners must navigate manually. Your organizational intelligence strategy must account for ecosystem coordination, because ecosystem coordination is what turns individual intelligence into industry-transforming advantage. The question in the OEM boardroom, the conversation from an executive conference room for a major OEM, let's call them Brand X, had started the way these conversations always do. Dealer performance, supplier updates, market positioning, operational efficiency, competitive benchmarks, all the familiar instruments that had guided the company's decisions for decades. Then the chief strategy officer asked a different kind of question. What happens to our business model, she said, when our dealers become more loyal to their own intelligence networks than to our brand requirements? She wasn't talking about contracts, she was talking about gravity. Progressive dealer groups were beginning to coordinate customer experience, inventory strategy, and service operations across Ford, Chevrolet, Toyota, and other brands simultaneously. Their intelligence systems were learning across rooftops, across OEMs, across entire customer life cycles. Customers weren't experiencing brands anymore. They were experiencing systems.
She described a recent dealer presentation where a network intelligence platform had optimized a customer's total automotive relationship, trading in a Brand X vehicle, purchasing a Toyota, and coordinating service across both. They had participated in the outcome, but Brand X had not orchestrated it. For the customer, she said, Brand X wasn't the center. It was one node. Then she asked the question no manufacturing organization ever expects to face. Are we still the architects of automotive coordination, or are we becoming a very advanced component inside systems designed by others? That is the question now sitting quietly in OEM boardrooms everywhere. In an intelligence age where advantage comes from coordination, not production, do manufacturers build the ecosystems or operate within them? The answer reshapes far more than technology strategy. It reshapes what it means to be an OEM. The OEM paradox. Original equipment manufacturers now occupy the most unstable position in the automotive system. They have more power, more data, greater reach, and more profound technical expertise than any other participant in the industry. And they have more to lose from how intelligence reorganizes it. OEMs are the only actors with complete visibility across design, manufacturing, supply chains, dealer networks, connected vehicles, and long-term customer life cycles. No dealer group can see the whole. No supplier can integrate it. No technology company owns it. From a capability standpoint, OEMs are the natural architects of ecosystem intelligence. From an organizational standpoint, they are the most exposed. The structures that created their dominance, manufacturing scale, brand control, channel governance, tightly managed value chains, were built for an era where advantage flowed from production and distribution. Ecosystem intelligence inverts that logic. It distributes decision-making. It shares optimization authority. It moves influence from ownership to orchestration, which means OEMs are not simply being asked to adopt new technology. They are being asked to lead a transformation that weakens the very mechanisms that made them powerful. That is the OEM paradox. Maximum leverage, maximum vulnerability. Where do OEMs fit in the intelligence era? If the industry was starting from a blank slate, manufacturers would be the obvious architects of its intelligence layer. OEMs alone sit at the intersection of engineering, production, telemetry, supply chains, service networks, dealer operations, and multi-decade customer relationships. They alone see vehicles not just as products, but as systems that live, age, fail, improve, and evolve across millions of real-world environments. They command resources on a scale no dealer group or supplier can approach. Their research budgets exceed the revenues of most retail networks. Their technical organizations already manage complexity that rivals national infrastructure systems. Their strategic horizons stretch across decades, not quarters. They coordinate thousands of suppliers, they govern global dealer networks, they hold longitudinal data across entire ownership life cycles. From a purely structural standpoint, OEMs are the only participants positioned to build intelligence architectures that span the full automotive ecosystem. No one else touches every layer. No one else can connect them. No one else can set standards that the entire industry must align to. And yet, why OEMs will struggle to move first? The same scale that gives OEMs architectural authority also makes transformation dangerous. Ecosystem intelligence requires opening decision loops that were once closed. It requires sharing forms of intelligence that were once sources of control. It requires coordinating value creation in ways that no longer fit neatly inside brand hierarchies or channel agreements. For organizations built on the command of production, this is not an upgrade. It is a surrender of old certainties. OEMs carry billions in infrastructure optimized for tightly managed flows. They operate organizations of immense political, regulatory, and cultural complexity. They answer to public markets trained to value predictability, not architectural reinvention. Ecosystem intelligence does not respect those boundaries, it learns across them, which means OEMs face a deeper tension than technology readiness. They face the challenge of leading a system that only works if no one fully controls it.
Control was never the same as coordination. For most of the automotive industry's modern history, control was the organizing principle. Manufacturers controlled production schedules. They controlled quality standards. They controlled dealer requirements, supplier contracts, brand positioning, and the cadence of innovation itself. When coordination was needed, it happened through hierarchy, contracts, and escalation. Problems moved upward. Decisions moved downward. The system worked because the environment moved slowly enough to tolerate friction. Intelligence was embedded in people, processes, and reporting cycles. It did not need to be synchronized in real time because nothing else was. That assumption no longer holds. Artificial intelligence does not behave like previous technology layers. It does not sit politely inside organizational boundaries. It becomes valuable only when it sees across them, when it learns patterns that extend beyond a single workflow, a single brand, or a single company. Which means the question OEMs now face is not whether they can deploy AI. It is whether they can accept what AI demands in return. Stage 6, OEMs and the reorganization of the industry. Stage 6 represents a deeper transformation. OEMs, suppliers, dealer networks, financial services, and service providers coordinating through shared intelligence rather than negotiated interfaces. Production planning links directly to dealer demand sensing. Service networks coordinate with supply chains. Product development draws on ecosystem-wide behavioral insight. Financial services price risk from real usage intelligence. No participant loses identity, but none operate alone. At this level, competition no longer happens between companies. It happens between intelligence systems. From here forward, the question is not who builds the best vehicles. It becomes who coordinates the best automotive ecosystem. Why OEMs become asymmetric intelligence producers. Network and ecosystem intelligence only work if participants contribute real intelligence. OEMs are not simply larger players. They are structurally different ones. They possess telemetry, engineering data, production planning intelligence, life cycle behavior across millions of vehicles, which makes them not just partners, but intelligence engines. Predictive maintenance, market demand anticipation, life cycle transition modeling, supply chain coordination. These are not dealer buildable capabilities. They are ecosystem foundations. And when OEM intelligence combines with dealer network intelligence, capabilities emerge that neither can produce on its own. This is where ecosystems stop optimizing and start innovating. The moment OEMs stop being the center by default, dealer groups are discovering something that manufacturers once held exclusively. When intelligence is coordinated across locations, brands, and customer life cycles, the system begins to outperform its individual parts. Not incrementally, structurally. A dealer network that learns across rooftops sees patterns a single store cannot. A multi-brand group that optimizes across OEMs understands customers more completely than any single brand ever could. A network that coordinates service, inventory, financing, and customer history creates continuity that customers instinctively trust. This is not a rebellion against OEMs. It is an adaptation to a different physics of competition. As coordination becomes the source of advantage, loyalty shifts toward whoever provides it most reliably. And increasingly, that loyalty is forming around intelligent systems rather than brand promises. From the customer's perspective, the difference is simple. One experience feels coherent, the other feels fragmented. They don't need to know why. They only know which one works. When coordination becomes the advantage. For decades, OEMs were the gravitational center of the automotive ecosystem. Dealers orbited brands, suppliers aligned with manufacturers, customers navigated ownership largely within brand-defined lanes. That structure was reinforced by physical constraints, manufacturing lead times, distribution limits, regional exclusivity, and information asymmetry. Intelligence removes those constraints. When dealer groups coordinate across brands, the center shifts. When customers experience continuity across OEM boundaries, gravity redistributes. When suppliers align with intelligence platforms rather than procurement schedules, influence migrates. None of this requires OEMs to fail. It only requires others to coordinate better. This is what makes the moment so difficult to confront. OEMs are not losing relevance because they are weak. They are being repositioned because intelligence changes where leverage accumulates.
The real choice. OEMs are making, often without knowing it. Every manufacturer is already choosing a path, whether deliberately or by default. Some are attempting to extend existing control models, adding AI to manufacturing, marketing, forecasting, and dealer oversight while maintaining tight coordination. Others are cautiously beginning to experiment with intelligence sharing, testing where coordination improves outcomes without fully surrendering control. And some are hesitating, hoping clarity will emerge before commitments must be made. But the industry is not waiting. Dealer groups are now building network intelligence. Suppliers are aligning with shared data platforms. Customers are responding to whoever delivers continuity, which means OEMs are no longer choosing if ecosystem intelligence will emerge. They are choosing who designs it, architecture or inheritance. This is the line an honest OEM assessment must define for itself. Will you architect the coordination systems that define the next era of automotive competition, or will you inherit them? Will you inherit? Architecting means setting the rules. Inheritance means adapting to them. Architecture allows OEMs to remain orchestrators, shaping how intelligence flows, how value is created, and how standards form across the ecosystem. Inheritance turns OEMs into highly optimized participants inside systems they did not design, where influence is earned through contribution rather than command. Neither path implies irrelevance, but only one preserves leadership. Why delay is not neutrality. Many OEM leaders instinctively reach for caution here, and understandably so. Ecosystem intelligence is complex. It touches brand strategy, dealer relationships, supplier dynamics, regulatory exposure, data governance, and competitive boundaries simultaneously. It feels safer to move slowly, but the danger is subtle. While OEMs deliberate, others are building, and once coordination patterns harden, they are difficult to dislodge. Intelligence systems are compounding, standards emerge quietly, expectations reset without announcement. By the time the shift is obvious, the center has already moved. This is not a call for reckless acceleration. It is a recognition that architectural decisions cannot be deferred indefinitely without consequence. Leading through coordination, not control, the OEMs that will shape the intelligence age are not the ones that cling hardest to authority. They are the ones who learn how to lead without monopolizing it. Coordination does not mean surrendering brand identity. It does not mean flattening competition. It does not mean abandoning manufacturing excellence. It means accepting that influence now flows through systems rather than hierarchies, and deliberately designing those systems. OEMs that succeed will become intelligence orchestrators, setting standards, enabling coordination, and ensuring that ecosystems they participate in evolve in ways that reinforce, not erode, their strategic position. Those that don't will still build great vehicles. They will so inside ecosystems whose rules were written by someone else.
The dealer OEM intelligence partnership. The greatest competitive advantages in the intelligence age will not come from OEMs or dealers achieving intelligence independently, but from dealer OEM intelligence coordination that creates capabilities neither can build alone. What dealer OEM intelligence coordination actually achieves for customers: seamless lifecycle experience, service decisions informed by engineering intelligence and local relationship knowledge, purchase timing guided by predictive maintenance data and customer lifecycle patterns, warranty experiences that coordinate OEM policies with dealer-customer relationships, financing options that reflect both vehicle lifecycle data and local market conditions. For dealers, enhanced intelligence capability, access to vehicle telemetry and engineering intelligence that improves service recommendations, predictive insights about customer needs based on vehicle behavior patterns across millions of units, market intelligence that combines OEM production planning with local demand sensing, competitive differentiation through exclusive access to coordinated intelligence. For OEMs, market intelligence and execution, real-time customer experience intelligence that informs product development and policy decisions, service intelligence that reveals actual vehicle performance across diverse operating conditions, market response intelligence that shapes production planning and inventory allocation, brand experience consistency through coordinated intelligence rather than rigid compliance. The multiplier effect of coordination. When dealer customer intelligence combines with OEM vehicle intelligence, patterns emerge that neither can see alone. Predictive replacement cycles based on usage behavior and vehicle condition. Optimized service timing that prevents problems before they affect customer experience. Lifecycle value optimization that serves customer needs while maximizing relationship profitability. Market adaptation that responds to changing customer behavior faster than competitors. Why? This collaboration is strategically critical. Dealer groups that coordinate intelligence with OEMs gain access to vehicle and market intelligence that independent operations cannot replicate. OEMs that coordinate intelligence with dealer networks gain customer and market execution, intelligence that direct-to-consumer approaches cannot achieve. Both gain ecosystem positioning that prevents displacement by pure digital competitors who lack the integrated physical digital intelligence that coordinated automotive networks can provide. The strategic reality. In an intelligence age where coordination creates advantage, dealer OEM collaboration becomes the foundation for automotive ecosystem leadership that neither can achieve independently. This is why the architecture versus inheritance choice facing OEMs directly affects dealer intelligence strategy, and why dealer intelligence development directly influences OEM ecosystem positioning.
Why this chapter matters. This chapter is not about technology adoption. It is about recognizing that power in automotive is redistributing around intelligence coordination, and that every ecosystem participant is either shaping that redistribution or being shaped by it. The strategic reality for the entire automotive ecosystem for dealers. Your organizational intelligence assessment from Chapter 10 matters not just internally, but ecosystemically. The intelligence capabilities you build will either position you as coordination leaders that OEMs want to partner with, or coordination dependents who adapt to systems designed by others. For OEMs, your architectural choices don't just determine your competitive position, they determine whether the entire automotive ecosystem develops coordinated intelligence or fragments into competing silos that require manual reconciliation. For the ecosystem, the organizations that recognize intelligence coordination as a collaborative opportunity rather than a competitive threat will architect the standards that define automotive's intelligence age. The collaboration imperative? Dealer OEM intelligence coordination creates capabilities that neither can achieve on its own. Customer experience that spans vehicle life cycles, market intelligence that connects demand sensing with production planning, service intelligence that prevents problems before they affect relationships. But coordination requires both parties to choose architecture over control, to design for intelligence sharing rather than intelligence hoarding. This is not about abandoning competitive positioning. It's about recognizing that the most sustainable competitive advantages in the intelligence age come from coordination capabilities that others cannot replicate. The manufacturers and dealer networks that confront this collaboration opportunity early will have the advantage of designing ecosystem intelligence together. Those who delay will eventually coordinate, but inside systems whose rules were written by others. And in the intelligence age, the distinction between architecting coordination and inheriting it determines not just market position, but market influence. The next chapter reveals why this ecosystem coordination opportunity exists now and why the window to shape it rather than adapt to it is shorter than most organizations realize.
That concludes Chapter 10 of From the Transactional Age to the Intelligence Age. Hillier has shifted the focus from individual organizational intelligence to ecosystem coordination and how it reshapes competitive dynamics across the entire automotive industry.
The key insight is that your intelligence architecture decisions don't exist in isolation. They're part of an ecosystem transformation where OEMs, dealers, and suppliers are all making the same architectural choice between coordination and control. The participants who choose coordination early will architect the standards that others inherit.
What makes this chapter particularly strategic is the exploration of the OEM paradox. Manufacturers have maximum leverage to architect ecosystem intelligence, but also maximum vulnerability because it requires sharing control mechanisms that created their dominance.
The chapter shows why dealer OEM intelligence coordination creates capabilities that neither can achieve independently. It's not about competition versus collaboration. It's about recognizing that the most sustainable advantages come from coordination capabilities that others cannot replicate.
In our next session, we'll continue with Chapter 11, The Pioneer's Strategic Choice, where Hillier explores the critical timing decision every automotive organization faces: when to pioneer intelligence architecture versus when to follow proven playbooks.
It's a crucial chapter for understanding the strategic positioning implications of being an early intelligence architect versus waiting for industry standards to stabilize.
Welcome back to our audiobook reading of Barry Hillier's From the Transactional Age to the Intelligence Age. We're diving into Chapter 11, The Pioneer's Strategic Choice. After 10 chapters of framework building and assessment, this is where Hillier addresses the critical timing decision every automotive organization faces.
This chapter is particularly strategic because it frames the choice that will define competitive positioning for the next decade. Do you build intelligence architecture during the formation period while standards are still flexible, or do you wait for proven playbooks and implement during the maturation phase?
What makes this chapter compelling is that Hillier shows this isn't really about AI readiness. It's about strategic positioning. The organizations that choose the pioneer path during formation don't just get tools earlier, they develop institutional advantages that later adopters cannot purchase.
The chapter explores both the risks and rewards of pioneering versus following, and why the timing of this decision has permanent competitive implications. Let's examine this strategic choice.
Chapter 11, The Pioneer's Strategic Choice. The strategic timing decision. When to pioneer versus when to follow. After completing the organizational assessment and understanding ecosystem dynamics, every automotive organization faces the same strategic choice: build intelligence architecture during the formation period, or wait for proven playbooks. This is not about AI readiness. This is about strategic positioning and timing. After all, it is 2026 already. The Pioneer Path. Building. During formation, 2024 to 2027. Architect intelligence coordination while standards are still flexible. Develop institutional AI literacy before competitive pressure intensifies. Shape ecosystem coordination standards rather than inherit them. Build capabilities that compound into systematic advantages. The follower path, adopting during maturation, 2027 to 2030. Implement proven intelligence coordination approaches once they stabilize. Avoid early-stage experimentation costs and architectural mistakes. Focus on execution excellence within established standards. Achieve competitive parity through disciplined implementation. Neither path is wrong, but they lead to fundamentally different strategic positions. The strategic reality. Organizations that choose the pioneer path during formation Determine what the follower path looks like during maturation. Pioneers write the playbooks that followers inherit. The question facing every automotive organization is not whether you're ready for AI. It's whether you're willing to accept responsibility for shaping what automotive intelligence becomes. Why pioneers develop unmatched institutional advantages. Organizations that engage during the formation period don't just acquire tools earlier, they develop institutional instincts that later adopters cannot purchase. The institutional advantages. Pioneers build leadership literacy in intelligent systems. C-suite executives develop an intuitive understanding of what creates coordination versus fragmentation. Management learns to direct adaptive systems rather than just manage static tools. Strategic decisions integrate intelligence coordination as a competitive factor. Cultural fluency in human-AI coordination. Teams develop natural collaboration patterns with AI systems. Generational differences become coordination advantages rather than resistance points. AI literacy becomes embedded in professional development rather than training events. Architectural intuition. Organizations learn to sense when intelligent systems need adjustment before performance degrades. Vendor relationships develop around coordination capability rather than feature competition. Investment decisions prioritize architecture value over tactical wins. Ecosystem positioning capability. Early ecosystem coordination relationships position for network intelligence leadership. Intelligence sharing agreements are established during formation rather than standardization. Market influence through intelligence orchestration rather than just operational excellence. These capabilities cannot be bought later because they are learned through experience, not taught through training. Organizations that wait for certainty miss the learning period that creates institutional advantage.
The pioneer risk-benefit analysis, what you pay and what you gain. Pioneer organizations absorb real costs that followers avoid, but they also develop advantages that followers cannot replicate. What pioneers pay: learning curve costs, failed approaches, organizational friction, temporary inefficiency, uncertainty burden, making decisions without established best practices or clear ROI models. Change management overhead, cultural adaptation, and human architecture development. Resource allocation risk, building capabilities before markets fully price their value. What pioneers gain: standard setting authority. Their successful approaches become the frameworks others adopt. First mover ecosystem positioning, preferential relationships with other early intelligence builders. Compound capability advantages, learning systems that improve faster than competitive copying. Strategic optionality, ability to shape rather than inherit intelligence coordination standards. The strategic trade-off: followers avoid pioneer costs but sacrifice strategic positioning. They achieve competitive parity through proven approaches but cannot achieve competitive leadership. The irreversible reality: there is no neutral position. Organizations that delay intelligence architecture development don't avoid the frontier, they arrive later under coordination standards established by others. The economic reality of intelligent systems: learning advantages compound. Organizations that build systematic intelligence early develop capabilities that widen over time. This makes pioneer timing a strategic positioning decision with permanent implications. Why this choice determines industry leadership. The automotive intelligence era is being written now through organizational experiments, cultural adaptations, architectural discoveries, and ecosystem coordination patterns. The organizations that engage during formation don't just implement intelligence earlier. They participate in defining what automotive intelligence becomes. This participation creates influence that extends beyond individual competitive advantage. Their coordination approaches influence vendor development priorities. Their intelligence standards become ecosystem requirements. Their architectural choices shape industry transformation patterns. Their success models become frameworks that others adopt. By the time intelligence coordination playbooks stabilize, the competitive landscape they describe will already reflect the choices pioneer organizations made during formation. This is why the assessment and strategic choice from previous chapters matter more than any individual AI implementation. You are not just choosing tools or timelines. You are choosing your organization's role in shaping the automotive intelligence age. Whether you choose deliberately or not, That role is being determined by your current architectural decisions and ecosystem coordination approaches. The next chapter shows what organizations are building when they choose the pioneer path and why the destination justifies the journey's uncertainty.
That concludes Chapter 11 of From the Transactional Age to the Intelligence Age. Hillier has presented the fundamental strategic timing decision that determines competitive positioning for the next decade. Pioneer intelligence architecture during formation or follow proven approaches during maturation.
The key insight is that this choice isn't about AI readiness, it's about strategic positioning. Pioneer organizations don't just implement intelligence earlier, they develop institutional advantages that cannot be purchased later. Leadership literacy, cultural fluency, architectural intuition, and ecosystem positioning capability.
What makes this chapter particularly valuable is the honest risk-benefit analysis. Pioneers pay real costs in learning curves and uncertainty, but they gain standard-setting authority and compound capability advantages that followers cannot replicate through execution excellence alone.
The chapter emphasizes that there's no neutral position. Organizations that delay intelligence architecture don't avoid the frontier. They arrive later under standards established by others. The timing of this decision has permanent competitive implications.
In our final session, we'll conclude with Chapter 12, The AI Future We're Building, A Vision of Pioneer Success, where Hillier shows what organizations are building when they choose the pioneer path and why the destination justifies the journey's uncertainty.
It's the culminating vision that brings together all the frameworks, assessments, and strategic choices into a coherent picture of what automotive intelligence organizations actually become.
Welcome back to our final session of Barry Hillier's From the Transactional Age to the Intelligence Age. We're concluding with Chapter 12. The AI Future We're Building, A Vision of Pioneer Success. This is where everything comes together. All the frameworks, assessments, and strategic choices culminate in a vision of what automotive organizations become when they choose intelligence architecture over tool accumulation.
This final chapter is particularly powerful because it's not about fantasy futures. It's about the logical destination already emerging from current pioneer development. Hillier shows what the competitive landscape will look like by 2030 and why the organizations making architectural decisions today are determining the standards that will define the industry.
What makes this chapter compelling is that it connects all the dots from the previous 11 chapters. Coordination debt, the 7-stage framework, executive leadership evolution, human architecture, into a coherent picture of organizational transformation that's already underway.
This is also where Hillier reveals the 3-tier competitive hierarchy that's emerging from pioneer development, and why the decisions being made in 2026 will determine which tier organizations occupy by 2030. Let's explore this vision of pioneer success.
Chapter 12, The AI Future We're Building, A Vision of Pioneer Success. It is difficult in the middle of a transformation to recognize that you are living inside the early chapters of a new era. In the late 1990s, companies rushed to build websites without knowing what digital business actually meant. In the early 2000s, retailers launched e-commerce experiments that barely resembled what we now consider online commerce. There were no playbooks, no proven stacks, no clean vendor ecosystems, only fragments, experiments, partial wins, and very public failures. The organizations that would later dominate digital retail, logistics, and platform commerce were not following models. They were discovering them. That is where automotive sits today with intelligence architecture. The automotive organizations conducting systematic intelligence development today are not implementing AI. They are doing something far rarer and far harder. They are discovering what intelligence-driven automotive organizations actually look like. Their current experimental successes are not endpoints. They are early signals, revealing the competitive dynamics that will define the industry over the next decade, when intelligence coordination becomes the foundation of market leadership rather than an optional differentiator. This chapter is not about fantasy futures. It is about the logical destination already emerging from pioneer development. The logical progression from current pioneer development. The intelligence architecture experiments currently underway across automotive organizations are beginning to expose something profound: competitive advantages that do not sit inside departments, tools, or programs, but in the way intelligence itself is organized. These are not incremental improvements, they are structural shifts. In the same way, e-commerce quietly rewired retail before the industry fully understood what had changed, intelligence coordination is now reshaping how automotive competition works, not through announcements, but through capability. What pioneers are building today is revealing the competitive requirements of tomorrow, the customer experience evolution that's already beginning. Current pioneer organizations are demonstrating customer experiences that cannot be recreated through isolated AI tools, no matter how advanced those tools become. These experiences are beginning to change customer expectations. What pioneers are proving now is simple but powerful. When sales, service, finance, and operations coordinate automatically around a shared intelligence layer, the customer stops experiencing departments and starts experiencing continuity. Customers who encounter this kind of coordination feel the difference immediately. They do not articulate it as AI. They experience it as being known, anticipated, understood across time, needs, and decisions. Once customers experience that continuity, traditional departmental excellence begins to feel fragmented, and expectations, once raised, do not retreat. This is why the shift is irreversible. Organizations that deliver seamless intelligence become the reference point. Others are no longer compared against peers, they are compared against a new experience category. By 2030, intelligence coordination will not feel innovative. It will feel normal. And organizations still relying on manual coordination will feel dated, regardless of how strong their individual teams remain. Why the industry will be fundamentally different in 2030.
The operational learning advantages that compound over time. What pioneers are also discovering is that intelligence architecture changes how improvement itself works. Organizations with coordinated intelligence are no longer dependent on manual optimization cycles, quarterly process redesigns, or isolated performance initiatives. Their systems learn continuously, insights propagate automatically, improvements spread across the enterprise without requiring translation. The result is not just better operations, it is a different improvement curve. Learning advantages compound, they do not plateau. Each interaction teaches the system, each pattern strengthens prediction, each coordination loop tightens performance. Over time, this creates gaps that cannot be closed by effort alone, because one organization is accelerating while the other is still iterating. By 2030, the operational difference will no longer be visible as better tools. It will appear as a fundamentally different organizational capability. The strategic positioning advantages that influence market dynamics. As intelligence coordination matures, it begins to do something even more consequential. It alters the organization's strategic posture. Pioneer organizations are discovering that intelligence architecture enables them to influence market behavior, not merely respond to it. They see shifts earlier. They shape customer journeys more deliberately. They align operations, partnerships, and investments around signals competitors have yet to detect. This is how competitive standards are born. Market leaders do not just outperform competitors. They redefine what customers expect. They normalize new levels of service. They set the pace others must follow. The intelligence coordination approaches proving successful today will not remain optional. They will quietly become the operating assumptions of automotive competition. The 2030 automotive intelligence ecosystem, the three-tier competitive hierarchy emerging from pioneer development. What pioneer experimentation is beginning to reveal is not simply winners and losers, but a new structural stratification of the industry based on intelligence capability. By 2030, automotive organizations are unlikely to differ primarily by size, footprint, or brand portfolio. They will differ in how intelligence moves through their enterprise. 3 competitive tiers are already taking shape in 2026. Tier 1, intelligence architecture. Leaders, the pioneers, approximately 15 to 20%. These are the organizations that complete the transition from connected systems to coordinated intelligence. They are building enterprises where learning compounds, customer relationships span full life cycles, and strategy is continuously informed by predictive insight. By 2030, they will have built customer relationships are managed as long-term intelligence assets, operations that improve continuously without manual redesign, strategic positioning that shapes expectations and standards, ecosystem relationships that generate network advantages. Their leadership is not sustained by scale alone, but by organizational cognition, an advantage that strengthens as it accumulates. Tier 2, intelligence coordination participants, the early adopters, approximately 40 to 50%. These organizations achieve unified coordination and participate effectively in intelligence-driven markets. They deliver consistent, seamless service. They learn across functions. They compete within the standards established by leaders. They remain viable, adaptive, and capable, but do not define the competitive frame. Their success comes from alignment. The leader's success comes from architecture.
Tier 3, individual tool optimization organizations, who is left approximately 30 to 35%. These organizations continue to build powerful AI systems without resolving coordination issues. They operate sophisticated departments that still require manual translation between intelligent silos. By 2030, their reality is not technological weakness, it is structural friction. They are capable, but slower, automated, but fragmented, data-rich, but coordination poor. Their challenge is not adopting intelligence. It is unwinding the coordination debt created before intelligence architecture was understood. Why this chapter matters? Because it reframes where you actually are. Not late, not behind, not missing a playbook. Early. Early enough that the standards are still forming. Early enough that organizational architecture matters more than vendor choice. Early enough that advantage comes from learning, not execution speed. This chapter exists to correct the most dangerous misconception surrounding AI, that the future is already defined and leaders simply need to select the right tools. It isn't. The automotive intelligence era is being written now, through experiments, partial successes, integration failures, cultural friction, and architectural discovery. Pioneers are not winning because they know the destination. They are winning because they are building it. The organizations that engage now are not buying an advantage. They are authoring it. And by the time the playbooks are clear, the competitive landscape they describe will already belong to someone else. A letter to an industry in transition. When I started writing this book, I wasn't documenting a technology transition from the outside. I was participating in it and realizing how lost the automotive industry felt. I've been through digital transformation since 1998 as an active technology participant. I've seen what happens when industries rush toward new tools without understanding what those tools are asking organizations to become. I've watched companies succeed by redesigning around technology's possibilities, and I've watched others struggle by layering new capabilities onto old structures. What struck me about AI and automotive wasn't the technology itself, it was the familiar patterns of confusion. Great leaders ask great questions, but lack frameworks to think through architectural decisions. Organizations are investing heavily in tools without understanding coordination requirements. Teams are seeing real AI value, but struggling to scale it beyond departmental wins. The same disconnects I witnessed during the early web, early CRM, and early digital retail. I don't know what the future with AI will look like. No one does. We're all in the formation period where standards are being discovered through experiment, not inherited through best practices. But I do know what successful transitions require: structure, education, and frameworks that help organizations think architecturally about technology rather than tactically about tools. That's what this book attempts to provide. Not predictions about what will happen, but frameworks for thinking through what should happen in your organization. Not certainty about vendor choices or implementation timelines, but clarity about the organizational decisions that determine whether AI becomes systematic intelligence or sophisticated coordination overhead. My hope is that the ideas in this book, intelligence architecture, coordination debt, the 7-stage framework, give automotive professionals better language for the conversations they're already having, better questions to ask about AI investments, better ways to assess current progress, better frameworks for designing human and technical systems that actually coordinate. The automotive professionals willing to think architecturally about those decisions rather than tactically about tools will be the ones who shape what this industry becomes. That future belongs to all of us. This book is my contribution to building it thoughtfully. Barry Hillier. That concludes our complete audiobook reading of Barry Hillier's From the Transactional Age to the Intelligence Age. Over 12 chapters, Hillier has provided automotive leaders with a comprehensive framework for understanding and navigating the shift from tool-based AI to organizational intelligence.
What makes this book particularly valuable is that it was written from inside the transformation while it's happening. Hillier hasn't waited for the patterns to become clear. He's provided frameworks for thinking architecturally about decisions that are being made right now while the standards are still forming.
The book's progression from diagnosis to assessment to strategic choice creates a complete roadmap. Understanding why coordination debt forms, recognizing the 7-stage maturity framework, assessing where you actually stand, and choosing between pioneering intelligence architecture or following proven approaches later.
Perhaps most importantly, the book emphasizes that this isn't just about technology adoption, it's about organizational transformation. The winners in the intelligence age won't be those with the most AI tools, but those who learn how to architect intelligence coordination while maintaining operational excellence.
As we mentioned, Barry Hillier isn't just writing about this transformation, he's actively building it. He's the co-founder of Automotive AI, an intelligence architecture company focused on helping automotive organizations coordinate knowledge, decisions, and customer relationships in an AI-driven world. If you want to learn more about their work in building practical intelligence architecture solutions, you can visit autoagentic.ai.
And if you want to learn more about Barry's broader work in technology entrepreneurship, strategy, and the Auto Intelligence podcast, where he explores how AI and global forces are reshaping automotive and mobility industries, you can visit barryhillier.com.
As Hillier concludes, the automotive professionals willing to think architecturally about these decisions rather than tactically about tools will be the ones who shape what this industry becomes. The intelligence age is being written now, and this book is a guide for participating in that creation thoughtfully.
Thank you for joining us for this complete audio reading. Whether you listened during your commute, while reviewing strategy, or just needed to absorb this content hands-free, we hope these frameworks help you navigate your own intelligence transformation.
The future belongs to all of us. The question is whether it's being deliberately designed or assembled by default. Thanks for listening, and good luck building the intelligence age.